Hello.
Hello.
Hey, how's it going?
Good. Is Mike around?
Not seeing him yet, no.
Yep. Yes, Stefan, I think I need to make you
Remember, there's like
presenter.
some, you need to like make something, I think, in like the
Mm.
left side menu, make presenter or something.
Yeah, I will.
Cool. I don't have anything for the actual intro as far as slides and stuff, but I do for the first talk. So.
Second. Yes. Where are you? Mode to moderate. I made you presenter. You should now be able to present something.
Okay. Yeah, looks like I can. 2 seconds. If I still remember how that all works.
Adrian's here as well.
Okay, that seems to be working just fine. Just turning it up for now, since that's fine.
Okay. You ready, Stefan?
Yeah, I just need to
Are we on
remember what the
time?
mute
Good.
button is, because I'm used to being home with a physical microphone,
Sure.
and I'm not home, so I'm just on a random laptop. But yeah, all good.
Okay.
You can go ahead.
So, hello everyone. Welcome to Linux Plumbers 2021 in the Containers and Checkpoint Restore microconference. My name is Christian. I'm one of the organizers of the Linux Plumbers conference and one of the organizers of the Containers and Checkpoint Restore conference. And note that this microconference runs from 14 UTC to 1930 UTC. We will have 2 5-minute breaks. The first one at 14:55 and the second one at 16 sharp. Note that 30 minutes after the end of this microconference, John Mad Dog Hall will be giving his keynote at 20 UTC. So go and check this out. This should be pretty good, hopefully. And also go check out the schedule. There's really good stuff happening everywhere today. And a few short things to note. If you're a speaker, I hope you had a chance to attend one of our speaker trainings where we have shown how to use Big Blue Button. If not, don't worry. The rest of the committee and I are here to help. When it is your turn to present, as will be the case for Stefan in a little bit, I will make you a presenter. And this will also allow you to start your presentation. And after I've made you presenter, you can either upload the slides directly via Big Blue Button or present straight from there, or you can share your screen with us. That's really up to you. Yep. And if you do have questions after a talk, please turn on the video and then audio once the speaker is ready. Stefan?
All right. Well, thanks for that, Christian. First thing, just as opening notes, because the first talk, actually, Christian and my presentation is going to be starting in 3 minutes. But I wanted to thank both Christian, who's been helping us, especially on the committee side of Plumbers, as well as some of the aspects of the MicroConf, and also thank Mike Rappaport, who's been really taking up, I think, most of the organization work this time around, chasing speakers and doing all of that stuff for us. That's been great. My time's been quite limited this time around, unfortunately. So it's been really great to see Mike do all of that. And I hope you really enjoy the schedule we have for you. Other things, this is going to be live streamed to YouTube, assuming everything works. And so we're going to have folks watch on YouTube, and those people will be able to join Matrix channels for chat. So there is a Matrix server that's run by Linux Plumbers. You should have received credentials and stuff by email earlier. Like, I think both today and yesterday we received some stuff for that. On there's a channel for the Checkpoint Restore, Container Checkpoint Restore MicroConf. So you can go in there, you can chat with others, and those folks who are not registered for Plumbers but are watching it on YouTube, they will also be able to join it. Now, apparently there's some issue with the Matrix server right now. I got an email from James Bottomley, I think, just a few seconds ago saying there's some issue. So we're just going to be assuming that it's some kind of, first day of Plumbers type thing. We'll see if it goes back online soon or what's going on. But that's a new thing that's available. And so that means that even folks who didn't pay and register for Plumbers do have a chance to both watch and actually contribute to those sessions. Otherwise, I just have the usual reminder that it's obviously always a bit late for that. Plumbers the microconferences are mostly meant to be discussions. Slides and stuff are fine as support material to kind of explain what the problem and idea and stuff are. But as much as possible, like try to involve other folks and actually have a discussion during this. And that's it. I think, did I miss anything, Christian? Are we good?
It's all fine. Mike, do you want to say something, Adrian?
Did Mike make it? I didn't see him yet on the list.
Mike joined.
Yeah,
Okay, cool.
Welcome everybody. I don't have anything more to add what Stefan and Christian said, so maybe Adrian has it. By the way, this year it's more checkpoint restore and containers than other way around.
Yeah, it is. Like, it's good to see. We always are quite interested in the checkpoint, especially the kernel side of checkpoint restore is what we're really quite interested in, and there are some good things. Like I won't be able to actually watch some of those live because I'm currently actually off in Europe, but I will be watching some of the recordings. Things like the GPU work on checkpoint restore seems particularly interesting to me.
Cool. Then our first session will be by Stefan Graber, and he will be talking about simplified user namespace allocation. Go ahead, please.
And not quite only me, but you too. Just as a reminder, like I think your name was supposed to be on
Fair,
it.
sorry. Yes, it is.
All righty. Let me just see. So the slide is good. Let me see if I can get the speaker console on the side. So I don't, because
Cool.
I'm, again, just on a laptop, no external display and stuff. It's kind of tricky. All right. So yeah, as mentioned, this is around the user namespace and some of its shortcomings, especially as far as consuming it and using it, and some of the things we've noticed over the years, and some ideas we have on how we could maybe make it more developer/user friendly to an extent, and also integrating, looking back at some of the stuff that's been landing in Linux over the past year or so, and how that might all fit together. So kind of going through the state of things first. And as a reminder, UUID and GID space in kernel is global. It's uint32 for both of them. That's also how, that's effectively what POSIX specifies, or how Userspace treats it in general. So not something we can just willy-nilly change. User namespaces can be created by unprivileged users. They effectively allow mapping. Well, for unprivileged users, they are mapping their own UUID and GID to anything that they want within that namespace. The unmapped, anything that's unmapped, so anything that's not available in a user namespace, is effectively unusable. and anything that comes from the outside of that namespace from a UID that is not mapped appears as the overflow UID and JID. That's effectively what you're expecting as far as current user namespace behavior. There are a number of privileged helpers to try and make things a bit nicer. So mostly thinking of new UID map, new JID map that come from the Shadow project. Those tools allow delegating a range of UID and JID to users. So you use ITSI sub UID, ITSI sub JID, which then lets you allocate ranges. And I believe, at least on Ubuntu, and I think a lot of other distros, the default tends to be 65,536 UIDs and JIDs allocated per interactive user on the system. The idea being that they can effectively run a POSIX compliant-ish environment using that range. It works. It does require a secure ID wrapper, which some people are not super keen on. I'm sure we can, maybe newer Shadow uses FS caps instead, but effectively, yeah, you need secure ID right now. It's one of the issues, like if you want a larger range, you're going to have to be kind of careful. You can change those settings, you can do some things there, but you don't want to really have overlaps between multiple users. And the same thing, you probably don't want to actually have any shared UIDs or JIDs. The issue being that if two users get to access them, they might not only be using them for a fully separate container. They might be able to just create a user namespace, use the UID in there, and then access resources on the host system that is owned by that UID. So say kind of the worst case scenario that we see happening over and over again is a system configured to do network authentication. Those will often use, say, a 200,000 to 500,000 range for network mapped UIDs. But then if this system is not configured specifically to avoid that, then some of those users will actually get a delegated UID and JID range, which includes those network users. And so they would be able to create a user namespace, get someone else's UID and JID effectively mapped into it, and then can access potentially processes or data that's owned by those users. So there's some difficulty there. It's nothing that can't be sorted with a lot of careful configuration, but keeping in mind all of the different cases of network file system, network authentication systems, variety of user space tools that do a variety of different things with the UID allocation, like especially using way past the usual kind of POSIX range. Like we've got tools now that do dynamic UID and JID allocation for specific subprocesses as like a security mechanism, and use UIDs and JIDs all over the place, making it really hard to get a safe chunk that we can then give for containers to users both process ownership and file system access. So yeah, there are some difficulties there. I think another case where we've had some difficulty is just when you run multiple container managers on one system and having to kind of deal with, mediating things so that they don't use, ideally so they use different ranges, or if they use the same range, that they use them at least in the same way, and there's no weird issues with those. So that's effectively the state of things with how user namespaces work, how the current configuration works when you want to do something more than mapping your own UID and JID, and how that can get problematic with some of the other tools we've seen out there. Did I miss anything on that, Christian?
No, I don't think so.
Okay, cool. So as far as rough improvements we'd love to see, and that we think would make for the experience to be quite a bit nicer, ideally, you would want user namespaces to effectively be able to use an entire UIN32 UID and JID range. That would be, perfect world. That'd be amazing. You can run any software. You don't have to care. Everything just works. Obviously, it's a good reason why it doesn't work that way right now. Like if it was easy to do it that way, that's how user namespaces would have been done in the first place. We perfectly realize that. We would also like to make it possible for fully unprivileged user to get a user namespace that has more than a single UID and JID. Again, there's a very good reason why it's done the way it is right now. But as a nice thing, as far as consuming user namespaces and dealing with them, that'd be great to have. We'd like also to be able to run multiple container managers on the system and not need any kind of collaboration, because we've seen that that gets tricky. Like behaviors change between versions, and like, I mean, in general, you don't really like having to deal with your potential competitor in general. So having to do kind of mediation around that has been problematic and often just not done, and causes a bunch of interesting issues. So if we can find some way to eliminate the need for that entirely, that would make a lot of people's lives a lot easier. And also, it would be great if we can somehow simplify the creation of user namespaces in some way, so to remove some of the difficulty and risks that can come with them. Like right now, so we need to deal with a bunch of security wrappers to do initial setup of those namespaces, and it's still gonna be needed in many cases. But there are some much simpler cases where we might not actually need any of that, and that might make it possible for a lot more software. Like you could think of just like running a command from a Python script or your web browser or whatever, actively using user namespace as a security construct. Right now, it's not super feasible because they would need to rely on the user having a range properly defined at the OS level, and which depends distro from distro to distro, and then knowing that nothing else is using those particular UIDs, and then using some specific UIDs for some specific things. It's possible right now, but it's such a headache that nobody does it. And it would be great if we could untangle things enough that it becomes practical. All right, I'm gonna try and go through the suggestion in ideally about 5 minutes or so that we get a remaining 10 minutes to kind of go through some of that, because I'm sure some people have opinions and we would like to get that. So some of that was presented to an extent last year. I think one of the confusion we had at Plumbers last year is that we were kind of tangling both the allocation of user namespaces in the way we would like to see them work kind of differently, together with the VFS issues. And we've luckily been able to untangle that a bit throughout the year. So VFS shifting is now very much a thing. Christian did a great job on getting that done. And that's been merged, and now we're adding support for more and more file systems. So that aspect can be kind of treated differently, and we can base some of the ideas to improve the overall user experience based on that stuff, based on those new features. So the rough idea we had, and I mean, really not attached to I'm more attached to fixing the issues that were shown earlier than the actual suggestion. So if anyone has different thoughts, we can definitely go over that. It's cool. The rough idea we had in the past was to maybe try and change UIDT, GIDT to be uint64 within the kernel, not in Userspace. Userspace would never see that, obviously, but within the kernel. And what that would let us is effectively have high and low 32-bit. I think the rough idea there being that high 32 would be a kernel identifier of sorts, and low 32 would be your actual the UID as it's visible to the user. What that then makes it possible is effectively you would clone or unshare, saying I want a new user namespace and I want it to be some feature flag, like whether we call it isolated or we call it simplified or whatever we call it. If you have that flag set, then you get a namespace in which you do have an entire UID, 32-bit unsigned UID and GID range. Every single UID and GID exist in that namespace. They are not mapped to anything. So you can spawn processes. You can mount, say, a virtual file system, like Temperfest, Fuse, any of those. You could mount them and you could write any UID and GID. It's perfectly fine. It's never hits disk. It never actually goes anywhere outside of that namespace. That would be perfectly fine. It would function. Now, where you're going to need to actually do mappings and some of the more complex, like privileged kind of setup is going to be when you want a container that's set up in that way to access the actual file system from the host. Like if you want to bind mount something into it, if you want to do any of that kind of stuff, then for that you will need to actually set up a map for those UIDs inside that completely isolated thing there actually translate to those UIDs going onto the actual file system. That's where some of the work done around VFS shifting and the new MANT API will help quite a bit with a lot of the semantics around that, I believe. That's mostly sort of kind of that aspect. There are a few other things I can go over as far as some of the weirdness that will result from doing something like this. The most obvious one, at least to me, is if you look at the process list, say PS or top or any of that kind of output. Right now, you see the owner of every single process. That won't work anymore because since a user will be able to clone and get an entire UID and GID range, well, you can't really represent that. They could run something as UID 1000 in there, and how do you differentiate that from the actual UID 1000 in the ancestor namespace? So the fact there being that for all of those situations, we kind of have two ways of doing it. One would be overflow UID. That's effectively what's done today for somewhat similar situations right now, where like you communicate between siblings that have no overlap. Then we use overflow right now. But I think something that could be possibly a bit cleaner is to actually use the owner of the user namespace. That is the UID and GID that initially unshared the namespace, and use that as effectively the owner for all of it, with then added fields to things like proc self status or the like, that will expose what the inner UID or GID are, so that tooling that does want to show it will be able to pull who owns the actual namespace, what the UID and GID is inside it, and show that as like separate columns or something if you're thinking of PS effectively. That's pretty much the rough idea. That also applies to a bunch of other things. I think I mentioned on the slide, things like UCreds, like that includes a UID and GID, so you can have different ways there. Like, do we add an additional field that lets us know? So the UID and GID would effectively be that owner of the namespace out of the box to avoid breaking any kind of backward compatibility. But then add extra fields so that we can also know what the UID and GID is inside the container for anyone that cares. We might end up having to do some things like that. I think the main thing there is that we don't want to actually affect anything using the existing user namespace semantics and behavior. That nothing should change there. It should be a new way to allocate a slightly different way of doing user namespace. And it's going to be really, really critical that anything that's security sensitive will fail close. Like, we don't want to have to patch every single bit of kernel that deals with UID and GID and how what namespace would actually come from, like what container they come from. That would be extremely, extremely tedious. So instead, it would be much better to make sure that everything works the other way around. And you would need to go and in a few places where we do need to be really namespace aware, those effectively unbreak things by allowing them and by properly comparing the namespaces. Did I miss anything, Christian? Asking my resident kernel engineer, because I'm definitely not one of those. I'm a consumer of all of that stuff. I might have pretty strong opinions on how I would like things to work, but I'm not a kernel engineer. So, oh, okay. Christian disappeared. He just texted me that something broke and it's gonna be back.
No, sorry, I accidentally closed the session because apparently I can't deal with computers.
So yeah, I was just asking you, like, as the resident kernel engineer, to
thank
make
you
sure
very
that
much
everything's correct. And that.
Thank you very much for the summary and representing an idea you've already presented last year. And I think this summarizes it all. And with that, we should have 4 minutes for discussion before we need to move on, unfortunately.
Yeah, did I miss anything? Did I cover everything we discussed, like, when we wrote those slides?
Yep.
I see that Amir turned on his camera. I don't think we've got audio yet. So. Hey.
Hello.
Yeah. Hi.
obviously this thing is not supposed to nest, but I'm a little bit confused about the part related to nesting, because sometimes you want to nest user namespace more than once, and currently ID map mounts do not support that. I don't know what's the plan for the future. So can you say a few words about nesting, what is supposed to be supported, which use cases? And
Yes, I would definitely expect nesting to be a thing. Like, I don't see a problem.
well, not for that simple
Yeah.
thing.
So I don't see why you wouldn't be, because like effectively the idea is that like every time someone asks to clone one of those kind of user namespaces, they will use one of those 32-bit identifiers, and they will get a new namespace that stands completely on its own, has no shared UID or GID with its ancestor. So there's no problem with nesting that to any level. Now, where things get tricky is if you do want to share file system access in any way with your ancestor, then for that you do need to rely on the VFS ID map feature, or potentially other helping features that we need to sort that out. But the general idea is like, if we take it at its basics, I would like, as a completely unprivileged user, to be able to unshare one of those, make a empty tempfs, my root file system in there. So no shared file system whatsoever with the host, dump a busybox binary, and spawn that as my init system in my container. And I should be able to access every single UID and GID and do whatever I want, because I don't have any persistent file system. Everything is virtual. And I should not need any privileged helper whatsoever to do something like that. I will still do for like network and whatnot, but like until you need to share data with anything outside of your namespace, you should be okay.
Right, and except then you wouldn't have the high UID bits represent the root namespace UID, so that breaks.
Right. I mean, effectively, that high UID would be a effectively random value the kernel picks every time someone calls unshare. It would be completely invisible to user space. It's only used so that in kernel you can compare two namespaces. You know, this is 1000 in this one. This is 1000 in this one. This is not the same thing. Don't treat them as the same thing as far as access control.
Stefan's original idea here was that it's essentially like a cookie, right, for a namespace. But instead of his argument back in the days was that instead of having the cookie directly in the namespace itself, where you need to retrieve it every time, possibly requiring you to pass the namespace around everywhere, you can just directly encode it in the UID and GID.
Right. That way, that avoids having to modify every single thing that is with a UID or GID within the kernel, because that's the part that would potentially be disastrous if we get anything wrong. I think that was, I mean, to be fair, the 64-bit UID thing is actually something that was suggested by Eric Biderman 2 or 3 years ago at Plumbers, when we kind of talked through some of those ideas, like, hey, that's something we might be able to do. I'm not attached to the actual way, but that does seem like a way to fail safe instead of failing open, effectively.
Okay, I'm sorry.
It makes sense. Thanks.
I need to be.
I don't remember if the next one on us, Mike, do you know if the next thing is at half past or now? I don't remember.
The next one is at 30. We had
Okay, so
enough
still have 4
content
minutes to
that
go.
we essentially
That's only in 4
couldn't.
years.
Yeah.
Right. So the next talk, I mean, Stefan, you can also do this as well. We can also all just show up. Hello, Tom.
Yeah. So we can set up Tom now.
Yeah.
I said, like, I'm unfortunately traveling right now, so I won't be able to stick around much longer. But you can always hit up. Like, Christian will be around, so you can always talk to him, or you can hit me by email or anything. Actually, just before we switch side, let me just switch back here.
Yeah, call me names.
If anyone needs our email addresses or anything and want to chat about this some more, that's something we're gonna be definitely looking into more over the next few months, I think, to see what we can do. It's not the kind of thing where like it's an immediate blocker for any of the stuff we do these days, but we can see it being very, very good for adoption of user namespaces if we can make things easier. And it will also, like, we see more and more of those network authentication stuff and init systems deciding to now do some amount of UID and GID biased security features and all that stuff, it would be great if we could switch to that. But have some solution for that anyway. So hit us up if you've got anything. Very happy to have more chat at that point. And
Cool. So
I think Tom, you've got your slides shared and everything. So
we need to move on. Yeah.
Yep. Well, we don't need to. We still have 3 minutes, but.
I can't read a.
Yeah, it's hard.
I'm sorry.
We still have 3 minutes.
We're ahead for once. That's amazing.
Yeah,
great.
exactly.
Tom, I already made you a presenter.
Yep.
I think so. Already uploaded your presentation. This all looks good. Great. You probably know all the ins and outs of this. Any other questions?
Do you want me to wait till 30 after, or should we just start 2 minutes early?
I was just gonna check quickly, see if Matrix and everything went back online, because like for the side discussions after, that'd be great if it was working. Looks like it's loading here at least.
It could probably. So first, if the chat doesn't work directly for you in here, the integration could fail, for example. You can also just go.
And that's why directly to Element, but it's not loading either. I think the Matrix
To
server
the-
itself is busted right now.
You can go to the following. Well, I should.
Yeah, you can put it in the chat, but yeah.
Yes, I can put it in the chat. Great. I can put it in the shared notes. Those should work. And in the
But if
shared
you're
notes,
gonna be putting matrix.lpc.events, it doesn't work. The server is busted.
okay.
So that's actually it's loading right now. Okay.
Yeah.
So it might
So
be
I think this
just
is really
slow.
this was really just a search of people joining. And,
And
the
that's the risk
creating-
being one of the first micro conferences on the first day. So yeah, it looks like the chat is starting to reconnect for me. So I'll try and keep an eye on there. Christian will be there too. And I think that's a good way to chat after the talks. Also because we are live on YouTube in theory, and YouTube has quite a delay. It's got like at least 30 seconds up to 1 minute delay. So questions being asked on there might.
Yeah, I'm sorry, the chat
Otherwise.
issue is me.
Yeah.
We had a thundering problem on the Matrix server. It was my fault. It's set to lazy account creation. It's still got another 500 accounts to go.
All right. Well, hopefully it will catch up. It will be back online shortly, and yeah, people can chat on there. I think it's gonna be the easiest way to deal with those after talk discussions, especially since everyone on YouTube can also join in. So that sounds good.
Okay.
All right. I think we're now at 4:30 here, so half past. We're good. So Tom, go ahead.
All right. Yeah, so the Oracle database, obviously long-running enterprise app. In fact, 10 plus years of support is fairly common. So there are likely Oracle databases out there right now that predate systemd. So they're around a long time. Obviously, there are C Group v1 distros. There are distros that have switched over to v2 now. Many of the enterprise distros are still on v1. We're trying to get to v2, but we need this database app to be able to run on both. Easier said than done at times. So this is a discussion. We brought this up 2 years ago at LPC Lisbon. More of a what if, is anybody else doing this? Is anybody else interested in this? Definitely it was more of an idea at that time, not a lot of substance behind it. In the last 2 years, we've got a little bit of substance. With that said, we have a fair number of questions and discussion points from what we found. So first, kind of a summary of definitions. So what we've called as layer 0 is the sysfs itself. So literally, if you're going to fiddle with CPU.shares, for example, obviously the user has to have a ton of knowledge on such a system like that. They need to know the C group sysfs itself. Whether it's a v1, v2 box, they have to manage all the systemd delegation, as well as knowing like how powerful the system is. You know, how many CPUs are there, what other workloads are going on. Basically, this user is full out knowledgeable of the whole box. At layer 1, then we have the traditional libc group stuff that was made circa 2008. So CGget, CGset. Unfortunately, that doesn't hide a lot of details. You no longer have to know the sysfs details, but everything else you still need to know. What we started on recently, and in fact, we sent out an RFC for this this summer, is what we've called CGX get and CGX set. This is abstracted away the v1 versus v2 logic. So if you're on a v1 system, CPU.shares, whatever. You can talk with that. You can also talk CPU.wait. This layer will make sense of that, translate it, figure it out, and then write and discuss and talk to the file system with the right version. Again, this is out for RFC. Finally, the layer we really want to get to, we're calling layer 3. And this would be a layer that could handle the system dedelegation, could minimize the requirements of the user. And so the user would just say, I want 10% of the system, or I want a C group that, even being outside of the box, I want a C group where it won't get killed if we run out of memory. So set up OOMD or whatever you're using to manage your C groups. Tell it that this one's important and that it shouldn't be killed, or vice versa. Tell it that this one's unimportant because it's doing yum updates or whatever. So that's the background of our definitions. So like I said, current status. Right now we have no plans on changing layer 0. Obviously, changing the kernel would be detrimental to anyone. I don't foresee us ever needing to make those changes. Layer 1, in May, we added full C group v2 support. So cgget, cgset, all the standard libc group tools support C group v2. Layer 2, we have an RFP out. I have a link there. And that seems to be working fairly well. Obviously, we're using it in-house in some internal testing. I don't know of a lot of usage outside of Oracle. Again, that's not even committed, so I doubt too many people are using that. And then finally, where we really want to get to is this layer 3. And let me share what's the discussion points. So here's some of the topics I'd love to hear people's thoughts on right now. The C bindings for libc group were written, again, 2008, 2009. They expose a lot of the gory details of the internal library. Ideally, I'd love to get to a different area, have different bindings there. We've added a lot of automated tests around libc group, and we're using Python quite a bit. In the database, we don't use Python, but Python for our tests would be helpful. I was wondering if other languages are of interest. I'd love to talk about the layer 2 proposal, what we've put out there, get people's thoughts. And then finally, probably where I'd really like to spend the meat of the time, if we can, is discussing layer 3. So like I said, what APIs of interest to people? What are they looking for? How do we make this as user-friendly as possible? Because C groups are cool, C groups are powerful, they're a great kernel tool. My database team really, I don't necessarily want them digging down into the bowels of the kernel. And in some ways right now, the user-facing API requires that. On top of that, then, the goal would be to hide system D knowledge, so we can delegate if we need to. I don't believe any Oracle databases that are pre-system D will need these changes. I think they will go out of life before this comes into effect. And then finally, things like PSI and UUID, what Facebook has done. If we could make these C groups a little bit smarter and say, hey, I want this C group to be labeled as important and not get killed when I run out of memory. Or I want this C group, if we run into CPU contention, let's emphasize this C group, or whatever database ends up wanting. So yeah, that's my background. Thoughts, questions?
Well, you realistically need systemd integration, right? So that's one of the major problems that we experience. I'm probably summarizing things that most of you already know about. One of the main challenges that we have right now is that with so older versions of LXC, it's not as big as a use case for LXC itself, but for LXC, for example, we allowed users to spawn fully unprivileged containers directly from the shell. And obviously, in a standard setup, you want to use a dedicated C group for your container. The problem is that on a recent C group v2 only system, you cannot do this if you don't wrap around systemd run and related tools that give you a delegated C group. And the API that we currently have for getting an empty delegated C group that you need is really not nice. You need to do very complex dbus calls, which I think is really overkill. So one of the things we would need, for example, for runtimes, which I think would be necessary, is essentially one single library call, either be it in a libc group library or in a systemd exposed library, that essentially allows us to say, give me a delegated C group that is writable for my user so that I can move myself into this one and then create sub C groups and so on. This is really something that's missing. But I guess you're more interested in an abstraction of asking for example, how much memory do I have available, and not care about whether it's C group V1 or C group 2.
Correct. Although to answer your comment, we will have that same problem. Obviously, we need to make a delegated C group. So I don't want the database to have that knowledge, but we're going to face the same problems you faced in LXC. So yeah, let me reach out to the systemd team. That's been on our to-do list to work with them and try to get more closer interaction there.
Yeah, I think this is it's definitely needed. I think we have duplicated between a lot of runtimes and a lot of user space programs that do low-level C group interactions. We have duplicated or need to duplicate the same logic. Legacy layout, hybrid layout, so empty unified C group hierarchy mounted at sysfs C group unified.
Yep.
The other into separate controllers, and then we have pure C group V2 layouts. Correct. And depending on the layout, you need to perform different delegation steps and so on. So having this encompassed in a single library would help us as well. So far, it hasn't led to anything.
Agreed. Yeah. Two years ago, it was vaporware at best. It wasn't even vaporware. It was just straight up a wish list. I now have a handful of database teams on board that we're working with, so I think we're getting more realistic. But I mean, we face the same problems.
It's also more pressing, right? Given that we now have distros that more and more distros running on C group V2 only layouts.
Correct. And in fact, for Oracle Linux, we're strongly discussing switching to V2 for our next release. So it's imminent even now for the enterprise world. Obviously, it was some of the more cutting edge distros that switched earlier, but no, all of us are getting there.
There's also the issue of how do you want the level 3 information. There is in proc meminfo a field, I believe it's memavail, that tells you how much memory avail. It doesn't currently take the C group stuff into account, which is arguably a bug, but the question is, does the kernel do this and go through all the kernel abstractions and say this is what you've got for this thing, or do you do it with a complicated library, which you have to keep in sync with all the kernel changes?
That's a good question. In fact, that meminfo that came up with the rack, which is one of the Docker team, or one of the database teams here in Oracle, literally just a handful of months ago with us. And yeah, that was biting them pretty hard because they were like, it's telling me memavail is the entire box, which obviously is not correct when you're in a container. Ideally, solving as much of this in the kernel as possible would be good, because our library can be smart, but every time we add smarts, that's just another pitfall that we've got to jump and fix and keep alive. But yeah, that would be a good one I'd love to fix in the kernel.
Yeah. We had some conversations with the folks who maintained the memavail, that part of the kernel earlier, and they didn't shoot down adding C group knowledge to memavail, but they said it was one of those they'd have to see it to see how it works. But sure. Yeah. But I just meant, so it's a possible direction to pursue.
Yeah, thank you.
Yeah, I think what we need is just to gather sufficient support and then make a case that this is a use case that people actually have. I definitely can see the value in having something like this. I think there was a proposal even a few years back from people from SiteGround, and they did the hardcore version of this, of what we just discussed, and essentially retroactively namespaced meminfo directly. So you would have a mount option, I think, on proc, so that it would show you C group virtualized information. And this also applied to CPU info and a bunch of other stuffs. But back then it was shut down with the argument that it's not the kernel's job to do that.
What are your gut feelings? Do you think we could revisit that now, given containers are more prevalent, or?
I mean, we have already seen on list with some patch sets that people start to be more open about it than they used to.
So one
Yeah.
You know, but we don't want to change the interfaces that
Yeah.
say this is what the machine has. We need to
Yeah,
add
no.
the interfaces that says this is what your process has. This is what your
Right.
process perspective has.
Yeah, I'm just saying this was back in the days. This was one of the first approaches. Yeah, but yes.
So one question related is like how currently is being used, the mem available is being used for. So the reason I'm asking is like from the memory management's perspective, until we try to reclaim, or we don't really know if we were able to reclaim or how much memory do we have, unless we also proactively reclaiming and know exactly how much, like proactively keeping some free memory to make it schedulable, let's say. So coming back to mem available, how are people currently using it? Because it's kind of a big like number out there, but I'm not sure that it's really that helpful.
So I can answer at least for the database team I worked with. They literally were putting it in a report, and it was running within a container, and the container had 4 gigabytes. Don't know. The machine had 256, making up numbers, and then thus the report looked wrong. No one was actually actively using it in that case, but the report was misleading.
And that's kind of the big challenge. Unless you have the people who are actually using it with, or trying to get that information and use it in some way, you don't have the information need to design a useful user space interface.
Agreed.
I have a question, or more for like at a layer 2 related work is so one of the challenging we are having is the power users, or like I think I'm not sure is if the Oracle's database apps does many like subcontainers, manage those or stuff. Like for example, we have many power users. Let's say one example is the build service, build and test service. All like on demand, it creates subcontainers, run the builds or the tests and stuff, and then recycle them or
Sure.
delete them and stuff. So I'm just wondering how you are abstracting this whole subcontainer management for these power users on the V1 versus on the V2.
Sure. Yeah, no, good question. As of right now, excuse me, the database is not doing subcontainers. In fact, the containerization of the database is fairly new to them. Obviously not new to Linux, but new to them. So this has been an ongoing process for the last handful of years to figure out how to containerize them well. I don't see them at the moment going to subcontainerization, but that could change. As far as the CG-get, CGX-get, dealing with subcontainers, in theory, it should just work. With that said, I haven't tried significantly. I've been doing, so our automated tests are using LXC. We are not going down into multiple layers of containers though in the automated tests. I'm not even certain if I could get that up and running happily on GitHub Actions, but I would definitely try. On the other hand though, it should in theory just work. It doesn't have a lot of knowledge. So if your sysfsc group is mounted properly within your container, I would think it should just work.
We do nesting no problem even on GitHub. So we run tests. We have a large test suite that does this, doing nested containers, running Docker and LXD containers, running LXD within LXD, and yeah, it's really not an issue. You essentially need to just take care to mount C groups correctly within your container or in a format that the init system, if you're spawning an init system in your container, that the init system can recognize, and then it's all good. Then you can nest. Systemd nests fine as well nowadays, so it's really not an issue anymore. It becomes a bit of a more of an issue when you have stuff like C group v2 mounted on the host. I think we had to have covered this a couple of years ago already, and you have a rather old systemd version running inside of a container which doesn't know how to deal with C group v2, and because of how C group works, you cannot mount C group v1 controllers both in a v1 and a v2 hierarchy. It can only be present in one hierarchy, so you might fall on your face if you have a scenario like this. But even then, I think for most systemd versions, you should be fine as long as you can create named C groups and you have pre-mounted, for example, a name equals systemd C group somewhere on the host and make it available to the nested container or the container in general, then it should work.
That's one thing that's bitten us in the enterprise world, since again we maintain distros that last a long time. We have there's a couple of our older kernel versions or distro versions that have a systemd that's really weak with the v1 versus v2, and I've seen exactly what you're talking about, but those are fading out slowly.
The problems we once thought this was going to be a really big problem, but yes, maybe we can get lucky and it won't become as much of a problem as
yeah.
So one kind of like related here. So systemd, like I'm like we don't run the systemd, so irrespective of the systemd, I'm more kind of like many power users accessing directly the APIs, and let's say we mount the C group like correctly in their like it's visible the v1 and v2. I'm just wondering how is this expectation is like as we are migrating from v1 to v2, these apps needs to be changed, like how they are creating the subcontainers. Instead of like this, let's see, like C group is going to be transparently changing the underline using v1 or the v2 for the subcontainers. So mainly my question is like, are here like let's say we are moving from v1 to v2. Do we aim for more transparent to these such kind of power users migration, or do we expect them, or they have to change something the way they enter the C group, or the way they used to create subcontainers for memory separately, for CPU separately, but now it's a unified and had some other restriction stuff?
No, that's a good question. And in fact, we have a similar scenario with the database. Some database teams want to be very C groups hands-on, and some want to be more just give me some memory, or give me this, and you figure it out. And that's why we have the multiple layers. The more hands-on ones, I'm hoping can deal more with the thanks, Mike. The layer 2 level, so they can call CGX get. And if they want to speak CPU shares the whole time, that's fine. We'll translate for them. If they want to speak CPU weight or whatever, that's fine. We can handle it. Or memory.max, pick your favorite. That will give them the advantage of they don't have to know v1, v2, but they still have all the power and all the super, like you said, they're still a power user. For the non-power users, my goal is to get them more to the layer 3 of just give me this 10% number or whatever, and you go look and see what else is going on in the box, and you set up systemd for me, and I don't have to think about these things. So I think in your case, I would guess a lot more of your users would be more on the layer 2 side from what you said.
Mm-hmm.
So okay, so going to your layer 3, I'm kind of more interested in the memory control part.
Yeah.
So one thing, like again, challenge for us from v1 to v2 is the way the swap account, like the whole swap accounting like behavior has changed. So
yeah.
I'm just wondering how what's the high level we say here? Okay, give me some memory, or I'm not sure like what's the right statements to say here is, which will kind of transparently able to enforce on the v1 and the v2.
You're asking some of the questions that we've struggled with, because like you said, it's not a one-to-one mapping from v1 to v2, especially in cases like that. So I think we will do a best effort. And as of right now, since the database is the team driving this, I'm going to largely do what they prefer. With that said, we have a wide audience here, and I'd love to get other people's inputs because it's definitely be a compromise. And hopefully it's a compromise that the community could be happy with and not just the database. But I don't have a graceful, I don't know, Christian, do you have a graceful answer? I don't have a graceful answer on some of these.
Graceful answer being, how do we want to set values, for example, in the future? And I think the API should be abstract. I'm probably telling you things that you already know. I think the API should be abstracted quite properly, right? Ideally, the applications shouldn't know shouldn't know the difference between C group v1 and C group v2. They should just have a way of setting, I want this much memory and so on. And probably, and exactly as you said, one of the main challenges will be, I mean, what do we expose, right? One of the things that we could say is we only expose stuff that is available in C group v2 and nothing from v1. So if you want to do memory swap accounting, which is really complicated and doesn't, I'm not trying to insult anyone, but the memory swap handling in C group v1 really doesn't work. And it's really hard to use. It's really difficult to calculate the correct values. We've done all of this dance in like CFS itself to abstract this away. It's really not pretty. And it isn't available in C group v2 as far as I know, and there is no plan to do this in C group v2. So probably we shouldn't even expose it anymore in a new API. It just adds complexity, and it's something that we can't nicely support, I think. But yeah.
That one's that's a good example. That one's tough for us because one database team is heavily using the swap accounting. Yeah. So balancing that will be hard for us. But yeah, I agree with you.
I mean, you could probably expose it as an API that is agnostic towards C group v2 and C group v1. And if you're on C group v2 only and you don't have it available, then the function would fail with, I don't know, EOP not supported.
Yeah. Yeah, agreed.
Right, Shaquille, there is no plan to make this swap accounting stuff available in C group v2. I take it.
Makes sense, yeah.
Okay, I think with that we're nearing towards the end, right? And we will have a 5-minute break until, my God, I need to calculate what this is in UTC. 3 UTC, and we will continue with Pavel, who's going to talk about Creo and the new Mount v2 restoration that they've implemented. So see you at 5.
Awesome. Thanks, everyone.
Thank you, everyone. Thank you, Tom, for the talk.
We listed the breaks for 15 minutes, and the break ends in the schedule. The break ends in 10 past.
Yeah. Sorry.
So if people would like to join or leave, we'll see you in 10 past hour.
Yep. Pavel, you know your way around, or do you have any questions?
No, I didn't check loading the presentation, actually.
It should work. Don't worry.
Okay.
Okay. I think we are ready to go on. Pablo is around as well. This is great. So our next talk is going to be by Pavel about Mount V2 Creo the Mount V2 Creo migration engine. Pavel is part of the Creo project. And one cool thing to announce, there have been 2 people from the Creo project which have received the the Google Open Source Award this year. Adrian, who is organizing this conference, and Dimitri. So I just wanted to mention this while I have the occasion. So it's pretty cool. Congratulations. And Pavel, please.
I also approve your congratulations. Yeah, I need to share the presentation somehow. I didn't see the button.
Oh, 1 second. I probably haven't
Sure.
made you a presenter. I thought that, sorry about this. So you should be a presenter, and there should be a little
Okay.
plus sign. Yep, okay.
Let's try. Just a second. Really? Don't work. Let's try
There
it.
are 2 ways how you can do this. So there is either you can upload the presentation and share it directly, or you can do a screen share if you have it open in one of your browsers.
Let me try again. Share the screen. Okay. Okay, now let's download. How I download it?
Have you uploaded it to the?
No, probably not yet.
Oh, it's not. It's not. Just download it. And if you have it available in a PDF, you can upload it here in Big Blue Button directly.
Just move it here, yeah?
There should be a plus sign to the left side, and there should be upload presentation as one of the
Oh,
menu
okay.
items.
I see.
Yep.
Okay, almost there.
No worries. It's not just you that it's experiencing technical difficulties. It's also all of Plumbers. So you're not alone.
I'm not sure, but probably it's Wayland.
Yeah, that could be.
Okay, I edited, upload. Okay. Is it here? No, not yet. Oh, it's uploading. Okay.
I'm seeing something on the screen.
Yeah, it's here.
Cool.
Okay, some technical problems, sorry. Okay, as you already know, I'm Paul Tichemir from Virtuosa, and I want to talk about mounts. First, I will recall all the propagation problems a little bit from the previous presentation on LPC last year. Then I will talk about one another problem which deemed important for me, but was not included in the previous talk. I also shared it when sent letters to kernel mailing lists. And then I will talk about kernel patch status and probably most important, what we do next. Okay, let's recall what were the problems. First thing to mention is that Creo doesn't know anything about the history of creation of resources. So we always need to, we always see the final snapshot and need to reinvent the history, the sequence which will lead to the same resource state after we restore it. So with only inherited mount sharings, we have multiple tricky configurations which are hard to understand how to restore them. You always need to think how to create access, how to not to create access mount, not to break the tree of mounts which you already have, not to lose the control over some mounts via over mounts. Need to always think how to put it all together in the right order. All those problems were discussed on my previous talk. Here's the link on the last slide. Okay, next. So the new problem is the order inversion. Here's the mount info-like table, which shows 4 mounts. You can see the first mount, I mean 101, is from the last shared group. It can actually happen. Here's the bash script, which can create such a configuration. And you can see on the right the picture of it. The tricky thing is that you need to create the mount, which is the ancestor of all other mounts. You need previously to create all other shared groups before. It creates another restriction on the order of creation of mounts, which affects crew directly. And you can see the GIF on the right, but it doesn't download. Sad. I probably will send it somewhere along with the presentation. The GIF should have illustrated that you need to create many mounts and do many unmounts to actually create this setup with old mount API. So yeah, we need to simplify mount API of creation of propagations. I mean sharing groups. And let's go to the kernel patch status. Actually, the original patch was sent in 2000. Oh, sorry, I forgot. Just a second. It was in 2017 by Andrei Wagin. And since then, we were facing a lot of problems in Virtuoso container migration related to propagation problems, like new mounts are created, extra mounts are created, which shouldn't be there, or some mounts disappearing after migration. That is sad. And it was a big pain for us, so we tried several heuristic approaches, like adding some checks if we need to do something, or if we need to set sharing, or probably set some mounts to slave. But that doesn't work because it was not general solution. It only helped in simple cases of our customers. So Andrei helped a lot, and for me to make actually another approach where we use his original kernel patch and on top of it create the new mount engine, which is much simpler than the first one and actually covers almost all the cases of propagation. I mean, all the cases of propagation, but some features still in to do. You will see them on the last slides. So I need to say big thanks to Christine for pushing this to mainstream, and to Andrei for helping a lot with review and supporting this series. So yeah, it got to mainstream like last month, and hope it would get into 5.15 version. Okay. So the API is quite simple. We just reuse the mount move syscall, adding one extra flag, which changes the behavior to actually copy sharing instead of moving mounts. So we don't need to change anything in old mount API. That's good. We also get cool new features of sysMoveMount, syscall. We can resolve paths at FDs. We can stop resolving at symbolic links. That helps a lot. Current Mount v2 implementation still doesn't use those features, but it would simplify quite much when we do. Also, we did extra security changes from the original patch. We added check that mounts can be accessed only by mount points. I mean, the destination and the source mounts both. Also, we check that we can't copy the sharing from the narrow root mount. We also can't copy sharing from the mount with locked childrens, which cover the root of destination mount. Generally, it means that we prohibit getting more propagation than the user can actually see at this point. We don't give additional ones. So I prepared a Creo port of our virtuoso version of Mount v2 algorithm, and it actually works, but with small restrictions that it doesn't pass all tests. For user namespace flavor, it doesn't go well, but in Virtuoso we pass those tests. So we need to port something more, but it was a draft proof of concept port yet. We will do a full port in future. So some more things, some more key things I need to highlight here, that we still allow, like it was in the original kernel patch from Andre, to copy sharing between mounts in different mount namespaces. It means cross namespace sharing copy. That can be done even if we prohibit this. We can still copy cross namespace because there are cross namespace bind mounts now. You can see here the sequence of calls which would lead to cross namespace sharing if we prohibit it, but still use cross namespace bind mount. But it creates extra mount namespace, abstract mount namespace, and extra mounts. So let's save some resources here and don't do it. Let's allow the direct sharing copy. It doesn't seem a security issue. We check that both mount namespaces between which we copy the sharing allow modification for current user. So we have capsysadmin in both owner user namespaces. Also, there is a difference in checks between actual move mount and move mount with our special set group flag. We don't actually move mounts. We only copy sharing. So we skip all checks which are related to mount move. Like we don't need to check if it has lock mounts on top or something like that. Actually, we check it, but in different contexts. I showed it on the previous slide. Also, due to namespace lock, we don't race with waiting propagation. So there is no situation there in the middle of propagation, some mount will change sharing group. And also need to state clear that we don't create new mounts. We don't actually change the sharing group tree. So there should be no loops created by this new feature. We should be safe. Okay, next slide. What we want to do next? First is simple. We want to fix all ZDTM, zero downtime migration tests. We want to handle some complications which occurred during the switch to mount move. We need to, for example, for external mounts, we need to find the actual mount point on host, then recreating the mounts of container, because we prohibited to access by subdirectories. We only can access mounts by mount points. We need to surely reuse cool features of mount syscall. We need to copy only from the bigger mount with full file system root, for example. We shouldn't copy from the smaller, thinner mount to the wider one. Yeah, that should be fixed properly. But I think it wouldn't be so hard, actually. So yeah, one other thing we need to not to forget to document the new API. It's not yet done, but I hope in near future I will do it. Here are more complex ideas, what to do next. There is some of them actually include the problems I stated on the last LPC talk last year. For example, we need some interface to get namespace tag of mount, because like proc is connected with its PID namespace, NFS with network namespace. We need to get this information simple, so we need some interface here. Also, there's problem of Unix socket bind mounts. Unix sockets actually have a file on the file system. We have a FD through which we send packets, and we have a file which can be actually opened with special IOCTL. And we need to restore that information right, because the user can open this file and after checkpoint restore check if it's still the same file, if it's reopened. So I think we would need something like cross namespace bind mounts during the mount restore to solve it. Currently, CREU creates mounts in all mounts for all namespaces in one single service namespace, service mount namespace, and only then copies namespaces and puts only required mount in them and does pivot route to rip out everything else. So probably we should change it to something more dynamic, like just creating cross namespace bind mount with new mount API. Also, there is a problem that some mounts, due to user namespaces and copying mount namespaces inside the container, can be locked. And probably the user doesn't want it to change to be unlocked after migration, but currently it happens actually. That can be a security problem, so we need to have some interface to actually comfortably change the locked status of the mount, making it lock at least. Probably we can't unlock it. But yeah, we need something here. Other problems probably should be solved in CREU. We need to handle files on detached mounts. We already have some work on it for NSFS mounts. We would do it. We need to handle nested user namespaces somehow. Probably the same thing as for user sockets would work. Just creating all namespaces by cross namespace bind mounts from the clear namespace. Also, we still have a problem with overmounted slash in namespaces. There is still not so easy to get all mounts for it. Probably some hooks in eBPF can solve it. Alexander Mikhalitsin would probably say much about it in his speech. The last thing, we need to open overmounted files actually. we've prepared all this mount engine, but we don't open files which are on hidden mounts. But we can already, as we have, as you can check in my previous presentation last year, already all infrastructure for it. We already tried some part of it in Virtuoso and it works. So we will do it in mainstream Creo too. Here are links. Thanks a lot for listening. Probably you have some more ideas on this one and probably more problems. Here, please tell if you have.
Has the new mount engine already landed in Creo? Sorry.
No, not yet. Sorry. I waited for the kernel patch to land in mainstream.
Sure. I once, a while ago, I had a patch to use NSFS to get to get the information that you were talking about, like, for example, get the namespace tag of a particular resource via the IOCL interface that we already have in NSFS.
Yeah, for NSFS, it's quite good example. We actually use this IOCL in Creo already to get the namespace tag of another namespace. So we can adopt it to get the namespace tag of a file system.
Now, either that or whatever the information for reading mount options in mount v2 is, that should exist. It's supposed to be there. I haven't looked at that code lately.
For proc, probably I'm not understanding the question. Do you ask about this thing, the mount tag? Yeah. For proc, it is easy to get this information because there are like links on proc PID1, and you can understand from the from this link to which process you actually which process is the init of the PID namespace. So you can understand that, okay, this process is for this PID namespace, then this proc is for this PID namespace. But it's hard. It would be easier if you have like general interface to get for any file system the tag.
Yeah, there should be an interface part, at least, and there was at least in the design for mount v2 to read back all the information you need to mount a file system the way it's currently mounted. And if that doesn't exist, that's probably where the work should be put.
Okay, I will check it.
Yeah,
I didn't found it yet, but probably it's still there.
That's David's patch set. That's should be part of FS info.
Yeah. It didn't get to mainstream, I think.
Not yet.
Okay.
Okay, I think I should mute myself when I'm talking. I think that should be it for now. We can have 2 minutes to prepare the next presentation. So if we run into any issues, we can sort them out. So Pavel, thank you very much for the talk.
Thanks a lot.
Interesting. Happy that you were able to solve some of your problems and excited to see what ideas you come up with next. Always really good ideas coming out of the Creo corner.
Thanks, bye-bye.
Alex, I'll make you a presenter right now, or I made you a presenter right now. So if you want to put up your presentation already, or in any case, you can do that now. Yoo-hoo. Quick question, is the chat working or is it not? Because I'm not sure. James, are you around?
Yeah, it's still not really working. It works if you log in with your own client or by the Matrix website, but it's still not working on.
Okay, I was just trying to make sure that I didn't miss anything. Cool. Okay, I think it's about time. So Alex is here, and he is going to talk about, I mean, I don't need to introduce Alexander Graf probably. So he's going to talk about secrets in cloned snapshots. So Alex, please take it away. Oh.
Alex, there is no audio.
Yes.
There is a microphone icon down on your screen. Did you join as listener or as microphone?
So if you leave the meeting again, for example, that's one thing that you could do, and you join the meeting again, then it will ask you whether or not you will want to join with microphone or in listen-only mode. And you probably selected the microphone mode, but oh, you didn't. Okay. Yes.
Okay, do you hear me now? Can you?
Yes,
can you
loud
hear me?
and clear.
Yes. Awesome.
Loud and clear.
Perfect. Then make me presenter again, and I'll put up the slides. That one. All right. Cool. So I don't know who exactly knows me in the room. I'm Alex Graf. I work for Amazon Web Services. My typical turf is more in virtualization, so I'm looking at this from a VM perspective. But the exact same problem set exists in basically any time you're trying to copy any workload and try to multiply it by a couple of times and then keep using it. So let's just dive into what the actual issue is. Let me see if this works. Ooh. So if you probably want to see me as well. There we go. So if you have a typical virtualization-based isolation environment with containers running in VMs, then you usually have your Linux kernel, you have some agent that runs inside there to take work, for example, and that's a typical serverless environment for us. Then you have an application runtime, say your Java environment, your JIE, JVM, and your application also wants to run some initialization code. Then only after all of those things are done, you can actually go and access a service. For example, a customer could then go and just try to access a website that you're serving or whatever it is that your thing is doing inside your environment. Now you see the arrow on the left hand side. All of that takes time. So every time we're trying to boot up any of these environments, any of these containers, or you could also think of them as just normal VMs. Anytime we do this, we just waste a lot of time and resources doing basically the exact same work over and over again. So the idea is, why don't we just go and save everything we've done until after the application init, which is usually always the exact same work if we have identity configured containers, and then just basically serve customers from that snapshot instead of serving them all the way from an initially coldly booted up VM. Now, the big issue with that is, apart from technical complexities, but like the philosophical issue is, there are secrets hiding in any of these stages. So secrets meaning some kind of data that is unique to that particular boot. Either a random number generator that was seeded using initial randomness, or a UUID that is generated to be unique to that particular machine you are currently looking at. Any of these, like if you're thinking of full-blown virtual machines, it could be USSH key pair, right? Anything that is generated on boot because you do need something secret along the way or something unique along the way that you assume 128 bits, for example, gets you enough uniqueness worldwide that generating it randomly just gets you a unique identifier. All of that is no longer true if you end up going cloning that system with the secrets included. So inside any of these stages, we have cached randomness, we have generated keys, we have unique identifiers, and sometimes we even have negotiated unique identifiers. So think of a handshake between a say database server and your client. Well, they do negotiate some unique identifiers to talk to each other on a concrete basis, so that the server knows what the client is and who the client is. Well, these no longer work if you start cloning the system, because you now have, for example, 500 different clones that all say I'm the exact same entity, and that obviously isn't quite true. So the basic conclusion that we came up with in discussions with the system folks and internally and a few others was that we do need to have two phases in addition. We need to have a phase that is quiescing the system, that is shutting pieces down or making them aware that there will be a snapshot taken of the system really soon. And then there should be an unquiet phase, and only after the unquiet phase is done, only at that end of that phase, we do want to be able to retrieve network interactions from the outside, which is the only thing that's actually observable from the outside. So during the quiet phase, we want to, for example, delete secrets to make sure that the snapshot doesn't include any secret material. We want to disable network access potentially, so that we don't have anybody talking to a service while we are in that limbo phase where we don't know if we have still old secrets or new secrets. And then after we are resuming that snapshot, we then want to go and reseed PRNGs to the random number generators. So the kernel one, OpenSSL has its own pseudo random number generator, for example. A few others, there are caches of random number generators all over the place. We want to generate new secrets, key material, UUIDs. We want to introduce a file like run sysgen ID is the current proposal. That contains a unique identifier string that an application can use to find out if something was updated to also make it possible to lazily identify whether the system was updated between point time X and Y. And then eventually enable networking again to get access to the system. So the current proposal of all of this is using system D inhibitors. And I can virtually see the room of people in this, like the faces in this room already start cringing. The idea is, like this is what we ended up coming up with through a couple of conversations with system D folks. It would work the same way suspend works. So you could have an application using a debug message. It would say, well, yes, you can go into this snapshotting state, but before you do that, please let me know so I can do some cleanup work before you end up going there. And the exact same for the other way around. After you've done snapshotting, after you're done resuming, it would say, yeah, sure, you can resume, but before you finish your resume thing, please allow me to do some work. And that's exactly the notion and the semantic that we could use to implement this. Now, the problem is how does that scale? So I mean that's the whole reason why we have this conversation, and I wanted to have this session at LPC. I'm interested in ideas and thoughts on who else was running into these issues and how we can solve them, maybe in a better way, or maybe this actually is the way that we really want to pursue. So this is great for an application. I have an application that has a debug client already, some GNOME thing, whatever it is. And that one can just go and register to such an event. That's cool for desktop systems, and if I really have a full-blown desktop VM, that works great. But then, does that really work in containers always? Do we have the mechanisms there? Do we even have debuggers there? I don't think so usually. Does that work in libraries? So if I am OpenSSL, do I really want to link against dbus just to be able to find out that something happened?
I mean, one of the things that you, so if you're coming from VM land, obviously, and in VM land, the question of whether or not what's running in the VM is usually, well, Linux system with an init system, right? And we do have a large amount of container workloads where we do run full init systems. Those wouldn't have a problem. But if you have come from the application container world, like Docker, Podman, and whatever it is nowadays, then you will have a problem because you will need, yes, you will need some sort of agent or something essentially that forwards to the container that this quiesce phase has now started. So yeah, you will need external tools for those workloads, and this will probably constitute most of the microservice workloads that you have, like all of the Kubernetes workloads and so on, probably.
Exactly, and they are really interesting for exactly that type of snapshotting and restoring. So what would be a great mechanism there, right? Let me throw out ideas that we came across. So one idea is I mentioned the run sysgen ID here. We could literally just have a file, and every time you're, I think I have. There you go. I have a snippet of pseudocode. You could literally just have a file, and every time you're trying to access something that is supposed to be unique in your code, you would just try to make sure that the file is identical. It wouldn't be as dumb as this code. It would usually go into mmap the file and actually do a mem compare. But the basic idea still stands, right? You would basically, every time you're like in your getter function for a secret or for anything that is supposed to be unique, you would always need to go in and check whether your file is identical. And that way you wouldn't need any of these dynamic mechanisms to keep to create this inhibition function, because we can basically make in a typical container world, the only entrance to the VM or to the container is through network. So as long as we make sure that we update this file before we open network access again, we usually are safe enough to not create races where you might be running a code path with the old generation and still handle a new connection.
I mean, it's way easier. One thing to keep in mind that it's way easier to interact with a container than it is with a VM, right? You don't have to just rely on network. You can also directly attach to the container's namespaces, for example.
True, but we're talking about snapshots here, right? So in that case, it would be Creo, for example. Creo would do the snapshot, and Creo could then again make sure that only after the file is placed with an updated ID, it would actually go and resume the processes that run inside.
So this would be bind mounted into the container, I assume. Oh, Adrian, sorry, you wanted to say something?
No, we discussed this shortly on the Creo side. Also, not for secrets reason, more for the our motivation was to help the JVM people, because they said they want to use checkpointing, but they want to clean up the memory a lot before they can do the checkpoint, because they can throw away a lot of things. So we also thought about it, but we also don't have a good idea how to do it in a good way. So I just wanted to mention this here. It doesn't help, but we are in the same situation definitely for Creo.
So how the run sysgen ID file is independent of how the notification comes to the container. This is what I wanted to ask, right? Because you said the container is, or VM is supposed to check this file, right? And it does get notified how? Via systemd, for example, or via another tool like an agent.
So all of that can be easily implementation defined. So the way we were originally thinking of this was to have a kernel driver for the VM Gen ID virtual device that Microsoft defines. And then as soon as that event comes in, you would basically go and generate that file again, but that again needs some quiescing of network. you could, like in an actual container world, it's much easier because you can control the file system from the outside.
Right.
So you can literally just like actually have that be a real file and just write to it, right? It could just be temp events in the file.
Yes.
For a normal container. In a VM, you could also just implement it using an agent if you wanted to.
Mm.
Question: does iNotify work across Creo checkpoints and restores? Because the easiest thing to do, I think, would just have whatever cares put an iNotify on that. You know, look for notifications that the file's been modified, like we do for directories and stuff, and then you wouldn't need anything external.
Yeah, the big issue when you get down to these super asynchronous interfaces, and iNotify is very asynchronous by nature, is that you never know when you're done. So the big issue that we are facing here is that we never want to be able to reply without reseeding randomness in the application. So let's just take an example. Assume you have an SSL thing, something that basically uses TLS internally, and we and the PRNG is already preceded in your snapshot. Now, if you resume using iNotify, if you resume and you notify that the resume happened only using iNotify without any checking that all the iNotifies are processed, then you may be responding to an outside connection with exactly the same random number as the TLS negotiation seed, which means that all of your TLS sessions will be insecure. Potentially. So you want to make sure you never get into that that race. You really want to make sure that every time you ever use a secret, after that checkpointing, that restore was done, that you ever use a secret, it always uses the new secret. And you never get into a situation where you may be potentially leaking old secret data in. Otherwise, yeah, not very secure.
Is the system call for getting a secret from the kernel so expensive that you don't just want to use that?
Yes, it is.
I think there was discussed on list, right, as well.
Yep.
Well, it's
like
not,
go ahead.
If I'm understanding right, it's not just where the secret is stored, it is operations in flight that are based on the secret, right? Like if I have some SSL session key or something, and I have started negotiating an SSL session, then I will have retrieved the secret from the kernel. And so your argument, I'm trying to think through how we would use this internally, and I think the answer is it could work. Your argument is that for running systems, you use the quiescing API, and for systems that use this file, you're insisting that all the network connections be torn down before and then recreated. You're not doing any TCP repair or anything. And that goes to tell you. So I'm thinking through gRPC and other, HTTP2, all those other interesting network protocols. You're thinking all of these, we would teach the library to say, next time you actually open a socket, or next time you open a UDP stream or whatever it is, check this file before you start. So even if you think you have a session to resume, check this file before you start.
Yep. Okay. Well, like in essence, what really will happen is that in the background, all of these are going to use just a lib crypto or whatever that is providing the PRNG for them. That really is the thing we care about. And that one would just on init open the file, mmap it, and then just every time you retrieve a new randomness hash, it would just go and check whether the contents change.
And so you're expecting that OpenSSL will return some sort of state error if I have an SSL object that is lasted across 2 different sysgen IDs, and then the higher level client will have to delete the SSL object and create a new one?
I don't think we can do that. That won't be a super breaking change for a lot of clients, right?
Basically, I'm thinking this has to be a higher level thing than SSL because it's connected to whether your TCP connection or your higher level HTTP connection is in use or not. And so it's not just the SSL library, it goes into the application protocol. And so the application protocol has to know I'm starting a new application level connection and therefore I need to start a new session. But I think it can work. I just think you need to teach the HTTP and gRPC libraries and all of that about it. You can't only teach OpenSSL.
I mean, this was one of the arguments raised in one of the threads that I saw in systemd, right? This is essentially a protocol that you need to plumb to all of the interesting applications throughout Userspace, right? So everyone needs to adhere to that, needs to learn how to deal with that. Yeah.
Correct. And then the question is how many shortcuts we can make by, for example, demanding that network is just torn down until we have anyone that not needs to dynamically retrieve secrets is up again. Correct. So you don't get into the situation where a session is already negotiated.
And this can potentially block indefinitely. Is there like some sort of timeout? Like, how do you think, like, for example, this happens when everybody has reported back until, Andre and KY have asked, I have asked enough questions, it's fine. Andre, I think you were first. Go ahead.
Do you hear me?
Yes.
So my comment is about the case when we want to migrate containers. If we want to migrate containers, we want to get the same secrets what we got on the previous machine. And we need to handle this case somehow too. And we need to remember this use case, because I think in many cases it's more interesting than just cloning containers.
I think they're all super valid use cases. But what would keep you from just copying the sysgen ID over and not injecting any callbacks?
We can do this. I just mentioned this use case just to remember that we have it, and when we're thinking where we want to save these secrets in the kernel, in Userspace or anywhere else, we need to remember that we have this use case and we need to handle it. It's not a question, it's just a comment.
Small comment here about the thinking and stuff. You want to throw away the secrets in your restartable whatever container shutdown phase, in the quiescence phase, not in. And so all restart needs to do is rebuild them, and then you don't have to synchronize. You don't have to wait until everybody's noticed. You do that all in your shutdown, your cleanup phase, and that's much easier.
It is easier to an extent. So let's assume we want to do this. What interfaces would we build for it? So again, we're getting back to square one, where we don't have dbus and systemd inhibitors in most of these containers. So what would the interface be to notify every single consumer of secrets that they shouldn't be doing secrets right now?
I mean,
and throw them all away.
There are two interesting ways that I could think about, but we should really get to KY's questions first, I think, because he's been waiting for a long time. Sorry, I'm playing the dad here. KY, please go ahead. Have you joined with audio?
I think he's rejoining. Where do you see that KY wrote something?
He had like raised his hand. There's like an option to raise your hand.
Okay.
Andre did this as well, and maybe I'm just seeing it.
Not
everyone else. Sorry. Okay. KY has rejoined, but only in listen-only mode. So KY, if you leave the session, you join it again, and then there's like an option to select the microphone, or join with the microphone, or in listen-only mode. So maybe try that. In the meantime, I think one of the ways is, as you said, implemented in via systemd, right? And every container runtime that we know about that implements a container runtime, which even for application container runtimes, they will have a stub in it. like a really dumb init system because they can't run their workload as PID1 for PID namespace specific reasons. It doesn't matter, but so you could either plumb it into this stub init, it would probably be separate patches to the container runtimes, or usually what is done is to bind mount some notification mechanism, for example, into the container. You could think about, for example, bind mounting a socket that you could subscribe to. That could also work, right? Why is everybody raising hands? Geoffrey?
I'll just go ahead then. I actually think it's easier, preferable to use the sysgen ID, assuming it works, because then you don't have to think about taking non-event aware libraries and making them event aware. You don't have to think about this library is meant to be just called with functions, and now I need to sort of asynchronously propagate some information to it. You just say, next time I call this library, it's the library's job to check when it calls a function. I think it'd be easier to integrate, especially with weird and legacy libraries. I can imagine stuffing the sysgen ID patch into a weird library much more easily than I can imagine, proper evented dbus support. So I don't know I'm curious what you think, if you think the dbus approach is preferable when you can use both.
Okay, just a quick interjection. KY is back. KY, you can go ahead if you want.
I don't see KY.
Okay, then we need to move on. Sorry.
Hello, can you hear me now?
I can hear you.
Yes.
Hi, thanks, Christian. Hi, Alex. On the very first slide, the problem you're trying to solve was to see, not pay the cost of all of the initialization that you had to do each time you had to start up an application. Clearly, there was a phase there that began initializing the application, but there were a bunch of things prior to that. What if we cloned prior to the initialization of the app itself, a lot of the app-specific state that is getting created that you're trying to solve here would go away, and still you could get some benefits of starting off at a much further point in the startup sequence. Do you have any sense as to how much of a savings this last step would give you, as opposed to just defining the problem away?
Yeah, that absolutely depends on your application. To be so vague. If your application is a super fast, I don't know, like Rust application, right? That just opens a couple of sockets and is done. That saving is not a lot. It's not a lot. You basically just save a couple of pages from disk, and that's almost it. And a bit of memory management setup, but overall like milliseconds probably. If your application is a full like 500 megabyte Java beast, we're talking seconds.
Okay.
Okay, with that, we are 3 minutes over, but I think this is fine because we run over into the break. We will now have a 10-minute break, or rather 7-minute break, and then
Christian, give me 2 seconds. Give me 2 seconds. If anybody's interested in the topic and is trying to pursue similar endeavors, or wants to just figure out how to best tackle it in a full community fashion, get to me on Matrix so that we can start to consolidate efforts.
Cool. They know how to reach you, I guess.
Well, I'm on Matrix. I'm on the channel, so
Yes.
Let's use the Plumbers tool.
Excellent. So we'll go into a break now, and then we will resume with Rajneesh talking about fast checkpoint restore for GPUs. So a Clio topic. Thank you very much, Alex.
Thank you.
Hey, David.
Hey, Rajnish.
David, are you our next presenter?
I'm not the official presenter. I'm part of a team with Rajnish and Felix. Felix will be running the presentation. Sorry, Rajnish will be running the presentation. But you know, we will be.
Yes,
me
excellent.
and Felix are here.
Yes,
no problem at all.
we'll be together during the talk, Christian.
I'm really just asking because I need to make one of you a presenter so we can upload the.
Yeah, so I think I can share my
slides.
screen in that case.
Okay, I just made you presenter, so let's see if that works.
Yep. Is my screen visible now?
It's loading right now. Yeah, now it's good.
Yeah, it's loading and it's visible. Looks good.
Cool.
Cool. See you in 3 minutes.
All right.
A quick mic check from me. Can you hear me?
Yeah,
Felix,
I can hear you, Felix. Yeah,
okay.
We can.
Yes. Okay, I think we're ready. We're right on time. Coming back from the slightly shorter break, and now we're going to hear a talk about fast checkpoint restore for GPUs from Rajnish, Felix, and David.
Hi, Christian. So can I go ahead yet?
Yes, you can go ahead. Sorry.
Please let me know when my screen is visible and loaded.
Not yet, for me at least.
Still not visible?
Nope.
Let me retry.
Oh, maybe it's just me, but
I just see the uploading button like circling around. I don't see anything else going on.
are you doing an upload or a screen share?
I'm doing screen share. So entire
Maybe
screen, system audio and share.
Yes, I see it loading now. Yep, there it is.
Okay, does it still look good?
Visible. Yeah, looks good.
Cool. So all right, so let's start. Hi, good evening, good afternoon, and good morning, everyone. I'm Rajneesh Bharadwaj. I work as a Linux kernel engineer for AMD. And today I and my colleagues, Mr. Felix Kuling, who is also our technical lead for Linux compute kernel team at AMD, and David Yatsin, who is also Linux kernel engineer, and we work together on this project. We'll be talking about some work that we are doing with CREU over the last few months. So before we talk about device files and CREU and its limitations, I think I would like to pause here for a second and just mention that we are using this CREU tool for last few months now, and our experience with CREU and the community has been extremely pleasing and very satisfactory. And but like any other software, CREU also has its own limitations. For example, its inability to checkpoint and restore any process that has device files associated with it. But strictly speaking, it's not necessarily a CREU's limitation. Basically, there is no real way for CREU to know, the device internal state. Or, for example, for a complex device like a GPU, there is no way CREU can know without external help from a driver or any user mode support plugin that can tell where the various virtual GPU mappings are and where the buffer objects, how are they created, how are they mapped, user mode queues, etc. So fortunately, CREU provides an extensible mechanism to extend CREU where CREU cannot deal with such things. And one such mechanism is a shared object mechanism of CREU plugins, basically. And that's what we used for enabling our work for checkpointing and restoring AMD GPU device-based processes with CREU. With current work, basically, we are able to checkpoint and restore compute workloads like PyTorch and TensorFlow. And we are going to talk about in subsequent slides about what we changed to CREU and how we edit the support using the plugin. So ROCm is AMD's proprietary open source developer platform for GPU compute. And to enable ROCm with CREU, we had to basically make changes, or our work was split into three major chunks. Portion of it went to the CREU itself, where we introduced some new hooks to the CREU. We are basically proposing these CREUs at the moment when we are talking, and our discussion with the community is currently under review as a pull request mentioned here. Then we implemented the actual plugin, which basically acts as an interface between AMD GPU driver and the CREU, and basically arbitrates the checkpoint and restore process. We are also planning to distribute it as part of CREU, and right now this is under review. And to make all this happen at the driver level, we also had to make changes to our AMD GPU, AMD KFD driver, and currently our patches are under review. We have done some API changes, and these patches are currently under review and also available on our GitHub page for anybody to take a look at. So this is the typical workflow, basically, and this is how CREU checkpoints and restores a process. So AMD GPU plugin becomes a part of CREU using the plugin extended mechanism. And you can see that we have, on the hardware side, we have a cluster of GPUs here. And in the kernel mode driver, AMD GPU driver, we have this ROC driver, which is a subset of AMD GPU driver and basically also known as AMD KFD. And this is the primary interface between compute applications and graphics hardware. So when Crew starts checkpointing, it attaches to a process using ptrace, standard mechanism, and it tries to drain all the metadata and the memory contents of a target process that it wants to seize and checkpoint. And how it does is basically by injecting a parasite code. And this parasite code helps Crew deal with the various VMAs and the memory regions using remote procedure calls. And once all that is done, the image files are written to disk. So we have extended Crew by supporting it with AMD GPU plugin that basically assists in the exact same process. And what it does is extra is when we are trying to checkpoint an application, the Crew calls back to the plugin hooks that we are implementing. And these hooks make call to the kernel mode driver and fetch the information like topology, various device C groups, virtual memory mappings, shared virtual memory ranges, and user mode queues and whatnot. And it feeds back this information back to the plugin, which basically save all this as part of image file. So we are also creating some extra image files in addition to the image files that Crew already creates. And finally, when all this is done, this image is ready, and this is ready for migration, maybe to restore on a same or a different node, or do whatever with this. So this basically contains the whole package. So this workflow is exactly the same workflow of a typical Crew checkpoint operation. So talking about AMD GPU plugin. So AMD GPU plugin basically supports various device files. Like I said earlier, dev KFD is nothing but the interface or the ioctl API for the KFD driver, which handles all the compute part, and several render nodes. So on a 4 GPU system, you will see 4 such nodes available. Right now, most of the KFD process state is associated during checkpoint and restore with dev KFD, and we are doing very little operation for each of these render nodes, except that we are saving some metadata. However, it could be extended in future for supporting some other things like Mesa video decode and encode. So the way it drains the GPU from these APIs is basically we call into these ioctls and we copy the metadata and the VRAM contents like various buffer objects, various type of buffer objects. We discover them and we copy them using the SDM engines. We'll talk about various VRAM copy mechanisms in a subsequent slide and that we experimented with, but the de facto choice is SDMA standard now, SDMA engine, and it makes it extremely fast. We support multiple GPUs. And at this point of time, we only support ROCm compute applications. We do not support Vulkan compute, any graphics OpenGL application, or like I said, Mesa video decode and encode at this point of time. And finally, we are saving all these and images, and we are adhering to Google protobuf format, exactly what Crew does, and we save these image files. However, we do see some limitations and regarding Google protobuf's inability to deal with larger buffer objects, and we would like to discuss here with the community. We have a separate file for this. So AMD GPU plugin basically implements some hooks here. Some of them exist in Crew, like dump external file and restore external file, and some of them do not. And we are proposing and requesting the Crew maintainers to, make them a part of Crew itself, because when we were developing this, we realized that not everything for complex devices such as the GPU is possible to be done in these 2 existing plugin hooks for external file dumping and external file restoring. We will discuss about each one of them in detail, but on a higher level, dump external file exists. It saves all the KFD process state and VRAM content for the process. Restore external files runs on the restore stage. It does the reverse operation, basically recreates the whole process and VRAM contents as they were before. We have update VMA map, which is used to restore memory mappings for the buffer objects that are recreated in the memory, and the new file paths if the restore is happening on a different node. Resume device late is a special has a special reason behind it, because and we'll talk about it in a slide in detail, but it's used to basically restart the user mode queues, MME notifiers, and restores the shared virtual memory ranges, and basically makes the process ready to run in almost the last and final stages of crew restore. And to make all this happen, and especially to make checkpoint work, we had to add this handle device VMA new hook, basically to detect any unsuitable mapping and make crew understand that this mapping may not be a regular file mapping or VMA mapping, but there is something that can deal with such things. So let's look at these in detail. But before we go there, I think I should also quickly introduce to the new ioctls that we are using in our kernel mode driver. They are all currently under review, and they are all basically used in conjunction with several plugin hook calls that we saw in the previous slide. First three, crew pause, crew process info, and crew dumper, are called in a separate context where the crew master checkpoint process is ptrace attached, and basically has hijacked the process, and the ioctls are called from not arbitrary but a known ptrace attached crew context. So our kernel mode driver knows that this is coming from a ptrace attached context, and thus it allows them to proceed. So for pause ioctl, basically when we start the checkpoint operation, we would like to ensure that the state, if there are some user mode queues running on the GPU, they should be evicted, or at least we need to make sure that the state is consistent between the checkpoint and restore. So we make sure that any running activity on the GPU is paused or quased for some time while this checkpoint operation is going on. And this can also unpause, like crew pause can do stop and resume both. Process info basically is sort of a helper ioctl. It runs before the actual dumper ioctl, and it determines the information. It discovers the underlying KFD or a GPU process, like what various types of buffer objects are there, and how much size do they have, and how much memory is needed to be allocated in the user space to drain all the content. So basically it does the discovery, and then we have the crew dumper ioctl, which finally like extracts the information, the actual raw data content from these discovered objects, and relays them back to the Userspace plugin, which then saves them in an image file. Crew restorer ioctl is run from a slightly different context. Basically, it's the target process which crew is morphing themselves into. So this is a slightly different context, and this is called in the context of the resuming task itself. And it basically does the reverse operation of what all the checkpointing did, tries to restore the buffer objects, every content, all the contents, all the metadata, make sure that every state is sort of recreated, but not necessarily fully restored at this stage. And why? Because for a GPU, we or any complex device, right, we might have some memory notifiers, or we might have some operations that need to be delayed until the VMAs are in their final positions. Basically, um, to sanely restart the memory notifiers and restoring the shared virtual memory ranges, the virtual memory areas within the newly created process address space have to be finalized, and that means that the PIC code had to be unmapped and not overlap with any one of these existing VMA ranges. So this crew resume ioctl is basically called from a separate context again, from a crew remote context, and this is called for each resuming task. And yeah, and we'll talk about it in the next slide, where we talk about the plugin that calls this ioctl. And they are also all of these are basically validated in the kernel mode with the right security privileges and capabilities. So KFD does that. So these are the plugin hooks that I was talking about. So the first plugin hook that we introduced to make the checkpoint work is handle device VMA hook. It takes a file descriptor and pointer to a struct stat, basically. So why we need this? We need this because currently Crew does not handle any VMA that it encounters that has any device file mappings with it. So basically, the way Crew works here is this: it looks at the processes proc PIDs maps and proc PID maps files and looks at certain flags. And if those flags have physical function or IO attributes set, they are not treated as regular VMAs by Crew. So this plugin basically gives a chance to any registered plugin hook to identify themselves and associate themselves with any such VMA that might have belonged to their device, or basically the driver can claim that, hey, this is mine. So this is the plugin basically that discovers availability of any such plugin hook. First of all, if nothing exists, then Crew simply fails to checkpoint such a process. But if certain plugin exists like ours, then Crew does not fail, and basically it only saves the metadata about these VMAs and expects that the plugin will take care of the rest of the checkpointing and restoring operation for such processes that has such VMAs. The other plugin hook that we are proposing is called update VMA map. And this is needed on the restore phase, basically, because on the restore, we cannot guarantee that the buffer object that we are trying to create again in the graphics memory will be at the same old offset as it was before, because there are some sort of yeah, they can be overlap, or that same offset can be now occupied by some other process claiming that offset. So there is no guarantee. So we need to tell Crew before Crew does, because Crew pre-maps all these VMAs in the position independent code in the sysmmap phase. So when Crew maps such a newly created VMA, then it will fail unless we update it with the new valid offset, because the previously saved offset may or may not be valid. So that's just an assumption, and we cannot rely on that. So we need to update Crew with the latest and the right uh, offset within the device file for that VMA that it's trying to mmap, and hence we need this plugin to be run in the PIC sysammap phase for all the VMAs that have VMA unsupported flag set. So it also updates Crew with the new file path. Yeah, because on the restore, we may restore on a completely different node, and the file path may not be the same. So it does these two things before Crew maps the VMAs in the restore phase. And finally, we have this resume devices late hook, which is sort of special because this does some special functionality which was not possible in the restore phase. So this is called at a very late stage, almost the end of a restore phase here, I should say, and this is called for each resuming task. So Crew basically, so the way we are proposing or modifying Crew is to call this plugin hook for every resuming task, and the plugin that responds to this hook has the responsibility of validating this process ID. And the way we do that is in the kernel mode. So kernel mode driver KFD, since it's called from a remote Crew context, so the KFD does not have the right struct to fetch the required information whether this resuming task is indeed a Crew, is indeed a KFD process. So that's all done in our kernel mode driver. So this calls the resume late ioctl that we just talked about earlier, and basically why we need is we cannot start the MME notifiers until and unless all the VMAs are finally restored in their appropriate locations within the address space of the restored process. So this can only happen at a very late stage. Hence, this needs to be done when all the tasks are almost ready to run. But we have no reliable way to figure out that which task is required to run such a plugin. So we regardless call it for all of them and leave the responsibility at each hook implementing this to validate the incoming target process ID. And if it matches a target device process, then it takes care of, it's expected to take care of the required operations in the kernel mode. So that's about it. Talking about VRAM copy methods. Over the last few months, while we were experimenting with this, we tried several techniques. Initially, we tried proc PID mem approach to read the VRAM contents when we are checkpointing. Basically, we read the VRAM offsets within the proc PID mem file at an offset that is nothing but the start of the virtual address that we are trying to read for the VMA. So this approach is very reliable, but it's extremely slow. I mean, it takes several minutes to checkpoint even small amount of VRAM contents. Let's say less than few megabytes, few hundred megabytes. It takes few minutes. So it is reliable and it's always available, but it's very slow because it's interfaced through the PCI host data path, and there are several bottlenecks here. There were several optimizations available on top of it. So we tried direct mmap on large bar GPUs, which was slightly faster than proc PID mem, but it's not always available because it assumes that it doesn't assume, but it expects that the PCI bar has to be a large bar configuration for this to work effectively. Then finally, we are now using SDM interface, which is always available. It's extremely fast and reliable. But the only downside is that it depends on two external libraries. So we have to use libdrm and libdrm AMD GPU because we are exporting the buffer objects and using the standard Linux DMA-buff technique to copy the VRAM contents. And since we are going through the libdrm interface, that's sort of a dependency for SDMA. But with this, the operations are extremely fast, and we are able to basically checkpoint few gigabytes of VRAM within seconds. We have thought about some security concerns and threats and possible mitigation plans. So my colleague and our architect Felix had chalked out several detailed plans on basically, and we wanted to discuss this with the community here as well. So we want to ensure that the read access to remote process state and the control of remote process execution should be sane, and hardware access to privileged state should be avoided, and it should be tightly controlled. It should be only available to the valid resuming task. But primarily, we are relying on the security policies that ptrace system call implements based on its attributes within the kernel for the checkpoint, and for restore, especially when we're restoring within a Docker or Podman container, we are relying on sysadmin capabilities and certain root privileges that are associated to effectively run the task. Then we also have some concerns about image integrity. So let's say, for example, the checkpointed image for a KFD process is tampered with, and on the restore, if somebody tries to alter the GPU state using some modified instructions there, how do we rely on image integrity? Can we only rely on the root capabilities, or is sysadmin capability a reasonable long-term requirement? Can we safely assume that? So these are the points that we would like to basically seek feedback on. But yeah, let me pause here for a moment and and request Felix if he has any further comments to make here.
Sure. Yeah, so like Rajni said, I think we're fairly certain that our approach to using ptrace is pretty sound. So ptrace already has checks in place to allow access to remote processes. And so we're basically extending that. And so if a process has ptrace access to a target process, then we're also allowing access to the GPU associated data for that process, and otherwise we don't. The biggest concern for us is basically when we're restoring an image and we're getting the image data from a root privileged Creo process. Is that enough to rely on the integrity of the image that we're getting, or is there a chance that the image could have been tampered with and the root Creo process just kind of takes the image and then passes it down to kernel mode? So in that case, there is a small amount of hardware-specific state in that image that would get loaded into hardware registers, and so basically a root process using that ioctl would be able to basically infiltrate the hardware with potentially dangerous settings.
It's, I guess, a good question for the Creo folks.
Hey, hi. This is Adrian. I hope you can hear me and maybe see me also. So first of all, I think this is very cool what you did here, especially because the Creo community has had requests how to interact with hardware devices like GPUs or InfiniBand, and our answer was always, there's the possibility to write a plugin, but nobody did until you came along. So this is really cool that you did it, and I saw your demo I think last week for the XOR conference. So this was really nice to see that how it works, and it was really fast. It was dumping like 5 gigabytes, and it didn't take a long time. So I think this is really impressive what you did here. I think you said at some point you think that protobuf is slow for storing the memory content of the VRAM, right?
Yes, slow, as well as like I listed down as the challenges that we face, especially when we encounter a huge buffer object in the VRAM, let's say greater than 4 gigabytes in size, it cannot.
Okay.
So my colleague David was actually working on making some optimizations there, and we're using the raw files. Yeah.
Have you seen, raw files. Have you seen how Creo manages memory, just the pages file where all the memory from the process, the non-VRAM memory is there, and it's just it's not a protobuf file, it's just a raw file with the memory pages of the process. Right. And then there's a page map which tells Creo where to put which memory content at which location. Have you seen that one?
Right. Yeah. They are like big files, 2 pages, 1 pages 2, and depends on like number of.
Yeah, but is that your idea? What you had for making it faster, the VRAM content on disk?
Yeah. So David, do you want to share your idea?
Sorry. Yeah. So yeah. I mean, we haven't I've looked at the page maps. Not like super in detail, but yes, it's very similar. We're looking at basically storing the contents with maybe some kind of ID for us to track where, the contents of each GPU is going. But the contents would be in a raw file because, but the main issue was, in protobuf there's a byte structure, and we have not been able to have a byte structure that's more than 4 gig. And if you have a GPU that has basically, let's say 32 gigs of RAM, we can have buffers that can reach close to that size, right? So we would have to be able to reach much bigger, let's say 32 or maybe 64 gigs in the future.
Yeah, but that sounds solvable, right?
Yes, with a raw file. With a raw file, yes, it is solvable. But we were just maybe asking about, whether exactly you guys have been facing similar issues, or you guys think of maybe a different solution by just writing raw files.
Yeah, I haven't been involved in that part, which wrote the pages file, but there are a couple of people here who probably know this in detail, and maybe they can help you or review what you're planning to do. And then about what Felix said about checks for the images, or if there's a verification what Creo puts into the hardware or into the kernel. I don't think there's anything Creo does. Creo just takes what's in the image files and it believes that's correct and writes it. Until now, we didn't write to any I don't know, GPU registers directly, so I don't think there was any harm writing the data there. I don't know if writing wrong data to the GPU can break it. I hope not. But as far as I'm aware, there's nothing in Creo there. So if you need something, you probably have to think about it.
Yeah, basically, we just wanted to know that is it safe to assume that those image files are always privileged and only root can access and tamper with them?
Yeah, basically the question is what happens with the image files between taking the checkpoint and restoring it? Who has access to those image files? But I guess that's more a question to the system administrators, right?
Yeah, this depends on who writes the files and who copies them where.
Yeah.
So does that mean that we need to implement some extra checks in the driver to basically make sure that our hardware state is sanitized before restore?
I don't know.
Let me ask one other question. So in the Creo images, I think there's other state in there that might have security implications. I think you're restoring like privileges of processes. So
yeah,
someone messing with the images could elevate the privileges of a process, right?
Yeah, I would say so.
When we dump and restore, so we're making use of Creo. Obviously, we usually we make the assumption that the directory that we're restoring from or the data that we are provided is in fact intact and is in fact trusted. And I mean, the simplest way of ensuring this is essentially by having a well-known directory that is only accessible by root or by privileged users, at least if you run Creo as root. So we, for example, we don't, but this is very implementation specific, so sorry if this isn't really helpful, but essentially we have a location where we know, which is where the container rootfs and so on is also stored. There is also a separate directory where we essentially keep the state for a snapshot that's associated with the container, and that's where we restore from. And that's the only part that we trust. We don't allow users to, for example, give us a random location where the state of the container is located. So in a complicated way of saying the application is responsible for ensuring the integrity.
So right now we are running these podman or let's say Docker containers with the sysadmin capabilities and root privileges, but I've seen talks and read about rootless containers with Creo. So how does this situation look like to you when we talk about rootless containers?
Yeah, so I think this is a complicated thing here. So 2 years ago, I think we introduced checkpoint restore, a capability to make this possible, but we haven't. So we have it in the kernel, but we do not have it in Creo. So the idea is we could theoretically, if we do it in Creo, we can at some point have it in a container engine, but this is really far away. For accessing a GPU is probably even more complicated than just a simple rootless container.
So, and in the rootless case, just to clarify this real quick, what you mean by this is that even the container manager is unprivileged, right?
Yeah, right.
Yes. So, okay.
And Andre wants to say something. Andre,
yes.
Come join us.
Yeah. Here we are talking about CAP sysadmin, but if we are talking about rootless checkpoint restore, we actually introduced the CAP checkpoint restore, and you can use it to control to check capabilities in your driver.
Sure. Is there any example of any consumer using that capability yet? Like, do you know any consumer?
I think you can grab in the kernel. We have a few checks, and we have.
No, in the Creo as a Creo consumer or a Creo client.
So we have pull requests with all these changes.
Okay.
And there are a few changes requested, and we need to just complete this pull request and merge it. And when we will have it, when it will be merged, we were able to set file system capabilities for the crew binary, and then use crew without so like any other binaries like sudo or
right
like this with file system capabilities.
right yeah yeah so thank you, and thank you Andre again for your help on this the ID caching problem that we were discussing on the pull request. So I think you already approved that change, and that now leaves us to one more open question, which is huge image sizes. So like David mentioned earlier, on a multi-GPU system, the total VRAM size can be of the order of few hundreds of gigabytes. So we haven't experimented yet with the deduplication and incremental checkpoints, but this is something that we would like to explore. And if you have any feedbacks or any guidance here, how to do it effectively for external devices, or whether or not the current capabilities of deduplication and incremental checkpoint in CREW, are they enough for this type of work? We haven't really explored this in depth yet, but this is something we would like to hear from you if you have any guidance for us here.
Yeah, I think the idea to use predump, it should help with minimize downtime.
Right.
But you will need to think how to implement memory tracking for GPU devices. I think it will be.
So does that mean we still checkpoint the whole like hundreds of gigabytes of VRAM image every time we checkpoint, even though we want to make a memory tracking and incremental checkpoint using CREW?
Yeah, for regular memory, we have memory tracking, and what we are doing, we freeze process for a short period of time just to get memory page maps.
Right.
Then we resume process and just we are dumping memory in the background, and all processes just continue working and everything. Then we do another iteration. We suspend process for a short period of time, get page maps, but this time we need to dump only the memory what have been changed from the previous iteration. So we have memory tracking, and we know what memories, what pages have been changed from the previous iteration. So we dump less memory on the second iteration, then we do another iteration, and when we see, okay, this is enough, actually on each iteration we need to dump more memory than on the previous iteration, for example. Then we do the full dump of all processes and resume them on another machine, or just save a snapshot on the disk. For GPU, you can implement something like this. I don't know how.
So the current CREW implementation only knows about the splice available memory, right, in the pages file that we have. So that's where it is operating. So do you think that we need to modify CREW also to make this happen, or this should be completely offloaded to the plugin? I mean, to do all the tracking for the VRAM and such things. Or is this something that can also possibly be extended to CREW's current memory tracking implementation? Like a different type of memory, like a GPU memory, not normal system memory.
So the short answer is I don't know. We will need to investigate how we can do this, because right now, if I understand what's going on there, that we don't integrate GPU memory to the CREW main agent.
Right.
How we dump memory.
Right.
And actually, I would like to. So I think the whole process of dumping GPU, it should be in a separate plugin. I think the choice to integrate this to the crew, it should be just the last choice if we understand that it's impossible to do this in plugins.
Got it. Okay, sure.
Because
Thanks.
right now we have AMD GPUs. In the future we will have NVIDIA GPUs, and there are thousands of other devices. So I think plugins should be a good choice.
Okay. Yeah, sounds reasonable to me. Yeah.
But maybe a crazy idea that we just mark this page that it's like plugin dumped page, but please dump it in page dumper of Creo. It would be probably okay too. Like just mark this page that content should be dumped in our page server way of dumping pages. Probably it's okay too.
I think you mean, can we reuse some Creo
Integrate. Yeah.
Yeah, we can use Creo code. We can share some Creo calls to plugins. It should be.
Yeah, provide an API.
Yeah.
I think that's a good closing remark. Thank you very much for that talk and for the discussion. I hope you received some input. This was really interesting work. Thanks for doing this. And we are up for another break for about 8 minutes. And we will be back at whatever it is in UTC. It's 7 CEST here, so I don't know, full hour at least. And then we will continue with Alexander's talk about alternative ways to
Sure.
extract
If I can
information
just
about
get
processes.
one
Sure.
quick minute here. So first of all, thank you everyone for listening, and big thanks to all the maintainers and the reviewers here. So like, do you foresee any major bottleneck in at least one of our initial pull requests? Do you see still any major ask or requirement that we need to fulfill to make the first pull request where we're introducing these plugins and modifying Creo to be acceptable to you?
So the first pull request is almost approved. So I think this is pretty close to being merged. What I want to mention here again, it's important that we somehow can include something in our CI run which tests this, because once you're done, it will probably break at some point if we cannot CI test this. So if you have a chance to give us access to something with an AMD GPU, this would be important for the future, I guess.
Felix, you want to respond to that?
Yeah, I agree. We are starting to talk to our DevOps team to see if we can have some kind of server in a demilitarized zone that is accessible from outside for that kind of purpose. I think it's definitely something we should be doing for the second pull request, which introduces the actual plugin and all that functionality. For the first plugin, I don't think it should be a gating factor, but I guess
no,
kind of commitment from us that, okay, we're really serious about this.
No, this was just, I just wanted to mention it with enough time for you to act on.
Yeah,
for the
definitely.
first one, I don't see it as important, right?
Yeah, and I definitely appreciate that. I mean, we discussed this over emails, basically that you're willing to take our plugin into your code base, and also that you're thinking about the CI problem and then making sure you're not going to break us. So we definitely appreciate that your help there.
Yeah, let me share my thoughts. As far as this piece of code in a separate plugin, I don't think responsible for this code myself. So for me, I think we can merge it without integration into our CI. But it is in your interest to have some tests and be sure that we will not break your functionality in the future.
Right.
Absolutely. Thank you very much, everybody, again.
Yeah, thank you.
Thanks again.
Thank you.
So, it's about time we can resume. I hope Alexander is here as well. This is our last session for this micro conference. And Alexander is going to be talking about alternative ways to extract information about processes together with Andre. Hey, you can start
Hi.
whenever you want.
Good to see you. Hi guys, my name is Alex Michalitsyn. I'm software developer and virtuoso, and today I'm going to talk about the ways to get information about processes. That's the main problem in CREW. First of all, I want to start from the problem of getting information about memory mappings. We know that we have special file called procpid smaps and procpid maps, which allows us to retrieve all needed data. But there is a problem because we can't change the format of these files, and these files have basically text format. And for CREW needs, it's not sufficient for us to have only maps file, but data and we get all needed data from smaps file. That's because this file have a field called VM flags, and also we have some statistics in this file, and that's the problem. Several years ago, during some experiments with live migration performance, it was discovered by Andrew that it takes a lot of time for CREW to get information about process memory mappings. It occurs when the container have a lot of processes inside and a lot of VMAs inside of these processes. Andrew designed and proposed a special kernel interface called taskdiag, which allows to retrieve data about tasks in the way like we get the data about processes about the network interfaces using netlink interface. Latest versions of this interface use only binary protocol part of netlink, but no sockets, no netlink sockets involved here. Just special file on procfs introduced, which allows us to use some transactional way to retrieve the data. Unfortunately, this interface wasn't merged to the kernel, and recently we decided to play with eBPF. Last years we see the extensive growth of eBPF, and one of interesting thing which paid our attention is eBPF iterator. eBPF iterators allows us to attach eBPF program and apply this program to some traversable structure in the kernel. For example, we have such iterators for TCP sockets, for UDP sockets, and so on. And last year, the new iterator was designed and implemented in the kernel. It's called Task VMA. This iterator allows us to traverse all VMAs for all tasks in PID namespace. We decided to try this to get needed information with some filtering and get some benefits in performance side. To achieve this, several new helpers was added to the kernel to have ability to call these helpers from eBPF program and construct needed data file. As we can see, we have basically two types of helpers. One helper is about printing PID information. It's like NS PID field in the procpid status file. And the second type is about printing some per VMA information. It's one printing binary format data about VMA. It's the borders of VMA, VM flags, page offset, major and minor for file mapped VMA, and inode number. And another two helpers is secure VMA name and secure spec name, which allows us to retrieve data only for some special VMAs. It's special VMA. It's about VDSO or stack or something another, for example, heap. And it's worth to mention that CRIO doesn't need to know from smap file information about path to the file, because we can retrieve, we can reopen this file using proc map files interface, and so we can take some time here. And I decided to make some performance test. To achieve that, I've used already written program from our CRIO test suite called ZTTM. It maps 06 program. This program creates a lot of VMA, about 30,000 of VMAs. I started 160 processes with maps 06 executable, and turned on BPF JIT. And also I have info about my node on slide. And let's take a look on some numbers here. We see several columns. The first two, we're pretty familiar with these two interfaces, and last third columns is about our new way with the BPF. This column is when we are printing data to secure file in text format from eBPF program. Not so optimal way. This one is about printing the same but in binary format. So we don't use printf here. And the last one is like previous one, but without calling the path helper for regular file. As we can see, we get almost the same result as with proc maps, but as I mentioned before, proc maps file is useless for CRIO needs because we need to know VM flags, but maps file don't contain these flags. And the reason why we have very similar numbers here is because we really have a lot of VMAs, but we have not VMAs, but not many processes. In my setup, it was about 160 processes from test and something about 200 processes from my system. Of course, we can assume that this maps file, we should open this map file for each process in the system, but when we're using eBPF iterator, we have one file from which we can retrieve information about all processes from this namespace. I also put some comments and explanations about the results. First of all, we have to know that smaps file contains some very costly function called smap gather stats. This function retrieves some per VMA information, statistical information. And this function contains the loop over VMAs, over the pages, and it's really costly. Another point here is that each eBPF iterator program runs in special context. We take in RCU read log, and also we doing migrate disable call. For my non-preemptible kernel, RCU read log have no any effect, of course, but migrate disable may eat some time. It's about 4% of total time from perf. This data gathered from perf. Another point here is that secu file implementation, which used in the BPF FS, slightly different than the original one, secu file, especially the read syscall implementation is different. We have fixed secu buffer size in eBPF, while we have dynamically changing buffer size when we use generic secu files. Another point is that DPass helpers, it's about 14% of time. And it's also worth to mention that BPF printf helper is slightly slower than the secu printf function. Another important topic for us, for CRIO developers, is the mounts. It's a pain for us because we have a lot of different hard situations when we need to retrieve some information about data, about some mount, but this mount was overmounted or something similar. And of course, we have mount info interface, but we have a lot of issues with this file because we can't extend this format, this file easily because it's used in many programs and we can't break the compatibility. Another problem is that this text file format and it's not fast. Also, we can't query particular mounts information. We meet last year when we working on the Docker support in CRIO. We meet the problem with overlay FS mounts. We wanted to know to get lower dirs and upper dirs and work dir paths from overlay FS mount, but we can't get this information because overlay FS saves this path during the mounting as it was provided by the user, but user may provide this path as relative. For CRIO, of course, for CRIO needs, it's not sufficient, and we proposed the patch to the kernel which just adds the dpath call and get the full path. But that was a bad idea because this resulting path may be very long, and we will meet the problem with performance from secu file side. As I mentioned before, we have dynamically changing buffer size and secu file, and we will get the several reallocations of this big buffer, and that's bad. Some time ago, we see that there is the great and ready to merge interface called FSinfo. This interface allows to retrieve data about mounts using the binary and easily extendable format. It even allows us to get information about particular mount by mount identifier. And I was experimenting with that subsystem and written support for overlay FS mounts and managed to get needed data about lower dirs and upper dirs and so on, like file handles. Using these file handles, I can reopen these files and get real full paths from overlay FS. That's what was great. But unfortunately, this subsystem wasn't merged into the kernel still. We decided to play with eBPF again, and I prepared the iterator, and the new iterator. Its iterator allows to traverse through the mounts of particular mount namespace by attaching this iterator to by file descriptor of some mount namespace. Here is a super simple example of a program which allows us to print the mount ID and parent mount ID and root directory iname for mount. But as we can see, we have full access to struct mount and struct mount namespace. So we can, for example, we can construct some code which may retrieve DPS from pass struct. We can construct pass struct and then call DPS helper and get the pass for mount or something similar. Time for some conclusions about all of that. First of all, I personally want to say that I believe that we need to utilize eBPF extensibility to create some interfaces when we need to get it to work fast. Yeah, but the great example here is Google Summer of Code project from this year by Kumar about UUID support. But when we're talking about some stable things like the process mappings information or mounts, it looks like we have a place to stop and think about some modern new interfaces which will be stable and allow us to get this information without any problems. The eBPF is great, but the problem with eBPF it's because it's comes from the helpers. We still have to create special helpers in the kernel, and it works almost like generic syscalls because if we add some helper to eBPF, it should be stable. And of course, it's not easier and it's not super easy to get this, to create this in a safe way. So anyway, we need to think on the interfaces here. I think that's all. Also, I want to say thanks to Andrew for his help and advices and ideas about this topic.
Cool. I mean, the FS info work is needed in any case, so I think that information, some of that information should definitely be exposed there. The eBPF stuff is really, I find really interesting. You said, so one of the restrictions that you correctly listed, obviously, is that it's restricted to CAPSYS admin, right?
Yeah.
And we are not foreseeing any future where we have unprivileged eBPF anytime soon, but we will have a way of doing signed eBPF programs, right?
Yes.
And I have no clear, hopefully someone from the eBPF crowd is here, but the way I envisioned it, unprivileged eBPF programs could work is when you essentially, CREO would ship an eBPF program. This is signed and that the kernel essentially knows about, which the administrator allow listed, I guess. And then you could even load these programs as an unprivileged user to figure out information. But maybe I'm totally living in a dream world, and this is not actually why we do get signed eBPF programs. But this, in my head, would be one way of making this more usable, because it is really powerful and is really easily extendable and extensible. And for CREO, this seems like something that would be really interesting.
Yep.
Did you have to implement anything in the kernel for this, or is this really just pure eBPF from Userspace loaded and figure out the information?
No, as I mentioned before, I implemented the kernel iterator for mounts and several helpers for getting information about VMAs. And also I've played with the Creo and made some patches to the Creo, which uses this new interface to get the information about VMAs. But I not prepared the pull request because anyway I need to post the kernel side at first and send to the mailing list and so on.
Sure.
That's...
Andre, go ahead, please.
So I have a question about performance. Could you switch back to the slide with performance numbers?
1 second, yes.
Yeah, here we can see that proc maps and eBPF maps just actually on the same performance level.
Yep.
If we look at task diag, we can find that task diag was something like 10 times faster. In case of proc maps, we need to open a separate file for each process. So the question, why eBPF is so slow?
Yep, as I said before, it's about, for my hypothesis here is that we have not so many processes in this setup because maps 06 tests generates a lot of VMAs, about 30,000 of VMAs, but I have something about 300 of processes in my system. Yeah, so it means that the open syscall will then we have something about 300 of open syscalls. Yeah, and that's not seriously, but the serious part of this time was in secure in read syscall, in secure read function, and we have almost all time working almost CPU working almost all time inside the BPF program. Yeah, that's why we have such numbers. Yeah. Also, it's worth to mention that DPass is really reflects on the results. Yeah, because when we get rid of DPass, we have the 15% improvement in the time. Yeah, that's good for us from the Creo side.
Yeah, I would expect. So if we have two numbers for eBPF in text format and for eBPF in binary format, and we see the difference between these numbers. It's quite big. Proc maps in text format too, and its performance, it's like eBPF binary format. So I don't know. I would
another argument here is that I have BPF JIT enabled, so it means that we have all working just like it's C code, yeah, written and compiled in the kernel. But as I mentioned before, we have some extra calls in the kernel just after and before each call of our BPF program. We have some RCU read log section. We have migrate disable, but as I said already, in my particular case, RCU read log not reflects on the result because I have non-preemptible kernel. So RCU read log is like no op. Yeah, but migrate disable have something about 4% reflection here. Yeah. But when I analyzed the general structure about persons of time where in which function we was during the execution, I see the topologically equivalent situation between the proc maps and our binary format. I think that it's just because we have non-fully optimized the code which JIT generates for us here, but that's a hard question, really hard question.
Okay, thank you very much. I think this is the end of the slot. This was really an interesting talk. I definitely like it better than the Netlink version. I'm not a fan of Netlink, but I get the point. I mean, task type was also a nice idea. Yeah, so thank you for attending this micro conference. I hope you learned some new things and heard some interesting discussions. We obviously can follow up with a bunch of these things in various email threads. We'll try to write up a summary again, as we usually do for the session, so that everyone is correctly informed. And with that, I thank you all for attending. Oh, I should probably do one last final thing while we're here. Second. Yeah, I want to thank all of our sponsors. I wasn't sure whether this would show up. So thanks to Facebook for being our diamond sponsor for Linux Plumbers. Thanks to IBM for being our platinum sponsors for Plumbers, ARM and Microsoft for being gold sponsors for our conference, and AWS, Netflix, and Red Hat for being silver sponsors. And the speaker gift is provided by Collabora, so speakers should have gotten something like this, a nice little solo key. And thank you to VMware for being our t-shirt sponsor. And conference service like Linux Plumbers, obviously we're a separate committee, but it wouldn't be possible without the support of the Linux Foundation, which helps us quite a lot when organizing this conference. We also have a code of conduct in place, which I think I've mentioned before. And that's all of the stuff I already explained to you. So with that, we're finished for today. And don't run away. In about half an hour, John Mattock Hall will give his keynote talking about 30 years of Linux, and this should be really interesting. And otherwise, I hope to see some of you tomorrow in the various sessions. Check out the schedule. We have a lot of cool content planned. We will probably also have some social events. Hopefully our chat server will behave better tomorrow. So sorry about that, but James is working hard on fixing this, and John and Guy. So thank you very much, and see you all tomorrow. Bye.